A very good morning, everyone. I hope you all are doing well. I, Vaishali Tyagi, welcome you all to the day two of the conference. After a successful session of day one of the conference, we will now be moving forward toward the session three of the event. May I request Professor Ashok Day to become the session chair of the session. We have with us Professor Dr. Amit Majumdar, Chief Technology Officer, Grandwood Technologies Private Limited, New Delhi, who will address the participants. Dr. Amit Majumdar received his MTech and PhD degree from IIT Kharagpur. He brings 3 decades of product development, manufacture process development, and technological commercialization experience in the field of stereography, storage media, photovoltaic, LED, and OLED technology. He has worked extensively in the collaboration with international top-notch technology-driven companies located in Japan, Europe, and USA for enabling the manufacture of state-of-art high-tech products in India. At present, he is associated with Grandwood Technologies Private Limited as a Chief Technology Officer. Dr. Amit has also published various papers in reputed international journals. Everyone, Professor Dr. Amit Majumdar.
Uh, Very good morning to everybody.
Good morning, sir.
Uh, Good morning. I really thankful to Professor Mehra. He's not there today. Uh, Give me this particularly chance to speak to this honorable guest. And yesterday, I attended the whole session. I see that okay. There are very nice talk and very elaborate academic research explained to us in the last day. Today, what I'm going to speak today actually, I changed my little, not mind actually, little change because as I am last 30 years in mainly the technology development and defined product development. So I used to do more development and small r actually. I say the big D, small r. So based on that, actually, that first half, I have two parts of the talk. One is that I just have some comment on what kind of technology trend is emerging in recent future, actually, and what happened in the past, actually. And second aspect, what I'm going to cover, that as a grant to technology, what we are doing in India, actually. And that is, we are doing certain application research with collaboration of the IIT, and that I explained in little details actually. So in the very first part, actually, you can see that last decades, actually, I am in the 30 years on the technology development. I have seen many times that due to the lack of innovation, that technology obsolescence is one of the biggest problems. And when the innovation is there, then technology is becoming affordable to each and everybody. So give me just one example. So last 10 years, I extensively working on the optical media, that storage media, the flash drive storage media. And the technology emerged in 1996 and obsolescence started in 2010 because somehow the innovation could not take place in that way to further improvement. It goes from like CDR, DVD, Blu-ray, people started with the holographic media. But due to the lack of innovation, the 16 billion or $20 billion market is becoming $2 million within 2 decades of time frame. Exactly same thing way that when we started working on the photovoltaics actually and PV, when we started working in this energy sector, and I think we had touched with the Professor Mehra for third generation solar cell, it is completely reverse. So when we started 2010-11, so people have only, whenever we go for any project proposal or any management, people used to state the two things. Can you meet the dollar per watt peak? Means for generation of the 1 watt peak, the whether product cost can be less than dollar. And second thing, that is it possible to have a grid parity? That means that cost of the power from the renewable energy, whether it can achieve the target of the price of the thermal power. But most of this, I think, participant knows nowadays that within 10 years time frame, the things have changed so radically that when we talk about the dollar, today we talk about the cents, that watt peak is becoming 20 cents per watt peak. grid parity, when the thermal power goes to 8 rupees, solar power is 2.5 rupees. So that happened only due to the huge kind of innovation happened in this particular field. And it is going to happen in the next 10 years because the world is moving in the renewable energy. That means that innovation without innovation, because I have seen that your research, I mean, that major topics is the academic research, but academic research
Amit sir, I think you have muted your mic.
is it visible that
Yes, 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 sir. It is
okay,
visible.
okay.
Thank you, sir.
So just I just looking, I mean, I'm reading some article that what will be the next 10 years, what kind of technology trend is emerging.
Amit sir, you're not audible, sir.
Now slide is visible now.
Yes, slides are not visible, sir. You,
Just sorry, I missed what happened. It's okay now.
uh, yes, sir. Yes, sir.
Okay. Okay. So just one report actually. Whoever the researchers, whoever the student, they should read this report. This is the recent report by UNCTAD based on the studies. They say that what kind of digital actually technology is coming in the next 10 years and what will be the market share. So, I mean, it's moved to a like a, I mean, I need not to explain all those technologies. So, there are 11 or 12 technologies which is coming already there and coming to the future. That is like gene editing, nanotechnology, blockchain, 5G, 3D printing, robotics, big data, solar PV, and drones. So that technology is moving to like a $350 billion to $3.2 billion trillion. So this is the recent trend. I think next 10 years will the world will decide actually that what is our lifestyle and what kind of technology is coming up. From this slide, we can understand that market cap is going billion to almost $3.2 trillion. Now, look into that, what kind of paper or other things is getting published actually in this particular technology. So already in the last 5 years, so these are the patent number that publication in frontier technology is artificial intelligence, robotics, nanotechnology, and this is the number of patents in the frontier technology happening in the next 10 years actually. So like it is going from 450,000 kind of number of patents applied for the AI, robotics, nanotechnology, big data, IoT, 3D printing. So these are the technologies. So whatever the recent trend of the research, what we are doing right now, it should be aligned with the what kind of technology is coming in the near future. Now, looking into that another data, when I can see actually from published by one of the So this is also one of the report I see the IBF that India is almost fifth, placing the fifth position in the R&D spending. So in 2020, they spent almost $96 billion in the R&D in Indian research, and this is the fifth rank in the world actually. But when we talk about that innovations, we are the 45th rank. So that's message just I want to leave, that when we are spending almost the rank in the fifth in the worldwide R&D, but in terms of innovation, we are the rank in the 45th. So why this gap? Basically, innovation, because whatever the research we do, unless it is implemented or it is applicable for the mass users, then that cannot be called as innovation, where everybody should work that how our researchers and how these our universities can do a value creation out of their research. And to create a value, I think one of the very critical things that there should be strong participation in the industry, because academic institute has their own limitation. They have a very good knowledge base, they have a very good R&D mind, but for the application or realization those research into the product, we need collaboration of the on the industry and make a bigger program. Under this bigger program, somebody can have a different kind of research and then create the value and have more innovation on that. So that's the message I want to give in the recent trend in this particular R&D. So the innovation is more, I mean, one of the critical things for the creation of the value. Now, my second topics actually, I'm going to tell that what we are doing as a grant company. So grant Technologies, this is a startup company, and we have this grant Technologies management. They have a very core knowledge in the display. With the IIT Chennai, Madras, we are doing many things, but one of the critical things that we are trying to establish a display technology leadership in India. So why we are doing, what is the reason for display technology? So let me say that for everybody's understanding, basically what is display? The displays are, I mean, everybody knows it, but just to set that tone right, I say that it is the windows of digital world data. And in the digital world, data is a first created, transmitted, processed, stored, and finally visualized in human readable from using the display. As the digitization is becoming very prominent in all the fields, so that display is becoming very, very important, particularly all the IoT devices, social media, artificial intelligence, and the requirement of the display is regularly changing. Now, data emerges from this digital highway into our physical world through displays, and display-centric products are today, everybody know, one of the major display-centric products is a smartphone, tablets, notebook, monitors, television, smartwatches, VR, handsets, automobile display cluster, all those things. Now, looking into that India perspective, today that there are maybe billions of mobile users, and the government of India and each mobile have a display. And if somebody look into the costing part, that display components cost us to 15 to 20% of the total bill of material cost. And that gives a huge kind of import bill to the government of India. As a result, government of India is trying or entrusted us to how to get the display business in India. Unfortunately, we don't have neither LCD or LED and other manufacturing. Now, generally, displays are two types actually broadly. One is called LED display. People say LCD display. The actual is the only one kind, that's a LCD. If the backlight is, replaced by the LED, then it is called LED display, otherwise LCD display. And there's another display called OLED display, that is the organic light emitting diode, which is the latest display started there. So basically in the display component, there is like a thin film transistor blackpen and coated with certain material in case of OLED. In case of LED, it have a backlight, then TFT backplane, and liquid crystals, and some of the color filters, and you get the LCD display panel. Now, if you see that market scenario today, because obviously it is academic research, but what I was trying to bring this point that unless there's a market pool, innovation may not happen because then it is not sustainable actually. So today display industry is reached almost 107 uh, billion dollar US dollar, and it is going to 226 billion dollar. And as we discussed that we have a two kind of display mainly. One is the LCD display, another is the OLED display. OLED display based on the organics. So slowly you can see that this is the movement of the OLED display. So this is slowly that OLED display in 2026, it will convert from to LCD to OLED by like almost 80%. Today, whatever we buy a high-end mobile phone, like above 30,000, they are all OLED display. And in case of and that is and the LCD displays are the low-end phone actually. So that's the market trends. That is the smartphone market is now larger, and consumers are now prefer more AMOLED display. The reason is the next slide, because if you see that. So basically, it's a bendable, foldable, those kind of flexibility in the AMOLED display, and those flexibility is not there in case of LCD display. So just let me explain that a little bit. What is AMOLED display or OLED display? Basically, it has a organic laminated diode. This is a current-driven light-emitting device and compromising mainly the functional layers. And this is they are called active matrix OLED, because each pixels you can actually control by using the thin film transistors. And normal layer we have a flexible, then we have anode, hole injection layer, hole transport layer, and then emissive layer, hole blocking layer, electron transport layer, electron trapping layer, and then you can get the light emissions actually. So this is as per the AMOLED display structure, and these are the benefit over the LCD versus OLED, because it gives the good image quality, because it can reproduce very nice black color. True black color is not possible in the LCD, but it is possible in the OLED. It can have a faster refresh. It does not need any backlight and wider color range and lower power consumptions. And moreover, you can make it flexible actually. It can bend, it can flexible. So these are the advantage of AMOLED technology. And that is the reason the market share is slowly increasing in case of AMOLED display. Now, these are the supply chain. I'm just skipping the slide for the time being, because when you have a display unit in this company, you need other industries too actually. You need like a sputtering target, you need the light management frames, you need the fine metal mask. So many things to make a device out of this display. Now, what we are doing in the AMOLED display project at IIT Madras. So these are the project entrusted by the government of India, particularly Ministry of Electronics, METI, Tata, and DRDO. And this, the market size as discussed is SCO. So government of India entrusted this project to have this grant with the grant to technology. So this is one of the projects that's why I want to showcase that it is a private and government partnership project actually. So grant to technology is giving the technology to IIT to develop a next generation of display. And as a CTO, I am controlling that product. And there are IIT from side, there are 5 principal investigators out there. A dedicated team is working in this particular display unit and make India a display-centric research and innovation at that particular center. So these are the overall project things that we do, that phase one, that development R&D, then we do the pilot plant, and this is the deployment of the commercial production. That is the total motto of this center. And Government of India is going to announce it as a center of excellence for the display. Now, how this is a integrated project, because this display project is not a simple just manufacturing a display, because it need the one of the things that LTPS TFT blackplane, that is low temperature polysilicon TFT blackplane. Unfortunately, India does not have that capability for any kind of fab industry. So because this is one of the bottlenecks, that's why we have to partner with some of the Asian company like Taiwan or somewhere else actually to get this LTPS TFT, because this LTFT TFT substrate is always customized for your product and product design. So a lot of design rules and design inputs are there depending on the what kind of display you are making actually. So in IIT, we are doing that, have a OLED deposition and OLED encapsulations, and trying to do, and when you make a display, it does not work automatically. You need a lot of electronics, lot of drives. So that's another project is going on, that how we can design those drivers and this for the display. So then we ultimately go for a panel design. So in this project, there are two aspects. One is the product development, and second are the underlying technology development or R&D. So this is the, fine metal mask. Then we have a process I explained to the CSS and CSS pastel process, how all those R&D. So there are group of students, actually group of professors, they are taking a particular research project based on this to basically support this bigger activity in IIT. These models, we are, always when this any private company goes to the IIT, it is very difficult. There are a lot of issues that how we can conjugate, because government does not give the money to. So basically, grant to technology, what we are doing, we have a licensed background IP. We have a some intellectual property, and we have a joint development partner. And when it creates the new IP, intellectual property, the IIT, it will be jointly shared actually. So all the background and IP for the grant at IIT jointly start doing, making a commercial product actually. So commercialization activity will be done by the grant root, and the basic research under the guidance of grant root technology will develop the product. In this particular product, because now question is that, already this display technology is there. There are Samsung, LG, they are making a lot of AMOLED device. Then what is the innovation in this particular product? So we have a technology differentiation that is called CSS process. We call the closed space sublimation. Normally, this any display technology, we do the linear evaporation process. Here we are going to do a closed space sublimation process. And if we are successful to do or demonstrate this CSS process, then entry barrier to having the factory, because normally any display industry needed billions of dollars. So we can make a micro factories using those particular technique, and we can have a, we can have a manufacturing capability. Plus, if we have our own IP, then that will actually, there'll be no entry barrier for the Indian company in this particular business. So that's why we are doing a technology that is a CSS AMOLED process, and grant root technology had certain patent for this unique process. Now, going back, that what is the CSS process we are doing actually? What is the advantage? So normally this, when organic films are getting deposited, it is linear evaporation. It is a continuous evaporate, and the glass moves and we get. So what we are doing, that we have first we deposit a small film on the glass, and then through optical radiation part, we actually, this OLED materials, the thin film will transfer to the product substrate. The product substrate means TFT. And these steps, so two-step process, one, the organic materials reusable, and then step two, those organic materials are delivered to the product substrate from transfer substrate. And these are all kind of vacuum printing. I cannot disclose the full because it's a lot of patent and a lot of other technicalities are there. So normally this process have a must faster be a 100% organic material, because one of the cost factor for the organic materials, which is very expensive, here we can material utilization move from 30 to 90%. As a result, the the actual display cost will go down. And another part actually in the display industry, it is called fine metal mask to make the pixels actually, to design the pixels. This is a maskless process actually. And so that will have a some business impact, like it can have a much faster cycle time, it can have a zero particle environment. So those are the, and we can basically for any kind of red, green, blue, RGB color device, we can actually reduce the material cost. So these are the key process of the pastel process actually. So we have like a TFT substrate, then we deposit one kind of OLED materials, then we do the maskless patterning through CSS process, and this is OLED 2, and this is cathode, and this model. Okay. That's the process we are following, and I mean we have now developing the Pascal substrate which can have a two heating zone. One is the cooler zone, another is the heater zone. So we can say the low reflective and high reflective zone, and we heat it. So there will be a difference in the temperature between the two spots. One is that we are talking the micron level actually heating, I mean thermal difference, and that gives the very selective deposition to making the pixel patterns. So this is the concept of equipment is already there. We have our own design of the equipment. So here, these are the organic chamber. This is a mask. This is the cathode chamber, and this is a loading chamber of the substrate. So everything processed under 10 to the minus vacuum level. This is a transfer chamber where substrate can invert, then go to that our new process. This is pastel stock chamber, that what we talk the CSS process. It will the patterning, then it will go to the transfer, and then ultimately, and then it goes for the bonding chamber. So this is a real picture of our AMOLED equipment in the R&D facility. We are making a prototype facility here, and this is, I mean, due to this pandemic, it is little delayed, but during the pandemic also somehow we managed to get the equipment installed, commission. Now we are doing all the kind of experiment. And this is a picture for using those bonding part, and this is the experiment we are doing. The project is managed a little bit different way, because it is typical the way actually the private, you can see that we have, I mean, we are making a, like, what is the key performance index. So the project is subdivided in 7 small projects, and who will responsible, and what kind of I mean target we have every quarter, and what percentage we are actually achieving, and then based on that it will be scorecard will be followed. It is typically, I mean, a culture of private company, but frankly speaking, today government of India may be also asking this kind of progress report every month actually. So we have a agenda how we can do the technology demonstrations. Then we go for how we are going to do the technology deployment. Then this is basically how we can do the center of excellence, because we have to spread this technology. I have a lot of partners on that. Then we have a strategic and commercial, how we can do the strategic and commercial, because generate all the IPs actually, like we have like around 22 IPs we have to develop in the next 1 year, and then how we can have a strategic partner for that particular project. And so this is overall technology roadmap actually. We 2009 we have a prototype facility. Then currently we are working on this particular technology. One is that existing technology, state-of-art technology, to understand that, okay, we can actually develop AMOLED, and then we are looking for the CSS process. And then we go for 2020 flexible, and 2020 we can do. So this is basically R&D part, technology required, R&D funding, then we have pilot material. And simultaneously, we are working with some of the Indian company where we can develop the OLED materials actually at inside actually, so that we have a very make up India kind of things, that where we can actually have a technology doing everything. So I can see another 1 minute, so let me do. So this is basically our big picture. We have to a roadmap for display industry creation in India, and that's the way actually. I mean, we have a like a understanding that we have a SKF display incorporation that they'll do the design, TFT backplane, panel manufacturing, and India. I mean, India means we will do the AMOLED design, panel manufacturing, and module assembly. And hopefully by next 2 to 3 years time frame, we are able to do uh, basically Atmanirbhar India actually, where we can make a display. And just for government of India already announced that expansion of India for the display, and some of the companies already applying. So we are looking to it, and they are giving lot of, I mean, they are already declared. We have published a big report where for as a expert that different kind of scheme that production linked incentive scheme and other things, how the government can encourage to have this industry in India. So I think we're thankful to METI because they are helping us a lot to basically encourage to the product development and R&D and technology development with IIT Chennai. Thank you very much, actually.
Thank you so much, sir. Please accept our token of appreciation from the team CIR.
Thank you.
Now I request Dr. Prabhakar Singh, Professor and former Head Department of Physics, IIT BHU, to deliver his talk. Dr. Prabhakar got his PhD in Natural Sciences from Institute of Physical Chemistry, University of Münster, Germany, and his MTech from School of Material Science and Technology, Institute of Technology, Banaras Hindu University. Currently, he is working as a professor in Department of Physics, IIT BHU. His areas of research are ion conducting glasses, materials for fuel cells, solar cells, electronic chemics, condensed matter physics, and renewable energy sources. Sir, all yours.
So, thank you, Vaishali. Am I audible?
Yes, sir, you're audible. Yes.
Yeah, thank you. Namaskar, sir. Namaskar. So, first of
Namaskar.
all, I'm
Very
ah,
happy to see you. Namaskar.
namaste, sir. So, I'm indeed thankful to Professor R.M. Mehra, who encouraged me to give a talk in this conference, and Dr. Shweta also. This is, I think, I'm just going to presentation mode. I hope that everything will be working. So, entire screen, let us see. It is not coming. Wait a minute, just a minute. I don't know. Okay, so is my screen visible?
Yes, sir, it is visible.
The band gap engineering, it is visible?
Yes, sir.
Yeah, good. Thank you.
Yes.
So now, is it in full screen?
Yes, sir, it is visible and it is in full screen.
Oh, that's good. Thank you. Thank you, Vaishali ji.
Thank you.
So, uh, so I'm giving a talk, just a general idea how band gap engineering can influence our whole life, actually, the surroundings and everything, and the materials, how we can make a band gap, and all these things I will talk about. And before that, we should just, for the physics students, I would like to just introduce what is band gap basically. So what is band gap engineering? So before that, we go to the band gap engineering. We should understand also the origin of the band gap theory, which is you know that if you are having a gaseous molecules, or the molecules or atoms which are separated far away, of course they are, if you calculate or if you take the spectra, you measure the spectra, you will find the line spectrum. But when in solids, actually the atoms are very closed, and you can see these, this separation is about A. It may be in angstrom, of course. So you see that when the atoms are very close, the outermost electrons, basically they are not separated. They are basically shared by those atoms also. And then when you make a quantum mechanics calculation, you will find that they will be separated in a group of energies, and each group of energy is separated by very small distances. And they are forced to do that because of the Pauli exclusion principle. You know that Pauli exclusion principle tells us that no two electrons can sit in a single energy state, and therefore the energy states are splitted, and they are formed in a group. And the groups of the different orbitals are separated by some energy difference, and that is known as the energy gap. And this is the reference is given, solid state physics. And then if you try to classify what the solids on the basis of band theory, you know that very easily you can distinguish, because in the metals there is no band gap between the conduction band and the valence band, and they are overlapping. So you can see this picture where there is overlapping of the Fermi level, and the Fermi level merged into the conduction band. And here in a semiconductor, there is, of course, there is a gap between the conduction band and the valence band. And when you have if you go to the insulators, this gap is wide, very wide, and more than 3 electron volt. So this is a kind of band gap. Now, why band gap is very important, and how we can create and how we can do the engineering, then we will see in next slides. You see that to manipulate the band gap of any material is very essential. And why it is essential? Because we need to have their application in a different scenario, in a different physical applications. So for that, we need to manipulate, or you can say that we can tune the band gap. Rather, manipulation, we can say that tune the band gap according to our need. And then you can see that this is the review articles. They are increasing very fast in the just manipulating the band gap and everything. So you can check it with this. Now, this is the review article. The band gap, which is tuned and aligned in a different range. Actually, suppose, for example, I take, these are the different range: infrared region, visible region, ultraviolet region, and of course the microwave and the terahertz regime. And these are the different materials. For example, let us say MOO3, molybdenum oxide. This can be tuned within the range of 2.8 to 3 electron volt. Similarly, if you take MnO2 randomly, then it is 2.2, and their application is from visible to the ultraviolet. And you know that any material, when the light or any form of energy falls, the atoms and molecules, they are going to the next energy state, and they are returning back. And correspondingly, they can emit energy in terms of the electromagnetic wave. These are the electromagnetic wave spectrum, which is shown in corresponding to different energy level, energy band gap. So they are the previously they are basically electronic band gap engineering, where we make manipulation of the energy band gap of material based on different, of course, the techniques, and we can also make the photonic band gap. The photonic band gap, they are also the similar form of the periodic optical nanostructure that affects the motion of the electromagnetic wave, and some of the crystals, they do not allow a particular band or a particular range of wavelength or frequency to go through, and that is creating a kind of band gap. And you can see, just I put a picture, this is butterfly, and of course they are having different colors and they are reflected back and reaching to our eyes, and then we can see and we can say that these they are containing the periodic arrangement of the crystals on their wings, and of course they are in a two-dimensional form. They are very, very thin actually. So this is the basically the band gap engineering for the photonic material, for the photonic band gap. This is the photonic band, and this is in our group. We are working on this. Dr. Jha is who is the basically the research associate who is working and on this material. So you see that this is basically a calculation which is finite element modeling simulation we did, and we found for different thickness. You see, this is for the TiO2 and the graphene. So we have plotted this omega with the different thickness. We took for two thicknesses just for demonstration, which is 10 nanometer and 50 nanometer, and we calculated this difference. And this is done for the difference of the material. You can see that these are the
Okay, excellent. Thank you very much. Okay, if you can see my screen and if you can hear me properly, I can start now. Would someone
Yes,
please confirm?
yes, sir, yes, sir. You're audible as well as your slides are visible, sir. You can continue.
Okay, now the topic of my talk is rather is a patchwork. I'm going to give you a glimpse of how electromagnetic waves can be of interest to us in our daily lives. It's not going to be very technical. If you're hoping it's going to be a lot of mathematics, you'll be disappointed. So I'll remain on the surface, but I'll be happy to take any specific questions. Now, let me jump into the deep end. Here, what you're seeing is a radar. Now, this radar is not meant for detecting aircraft or locating aircraft, but it is meant for recording echoes from clouds. So here you can see the antenna dish, which reflects any electromagnetic energy trained on this dish. The signal goes out, etc., and something comes back from a scatterer. A scatterer means a discontinuity, such as a cloud. So this is an example of an electromagnetic wave application, radars, and radars occur in almost every walk of life. Now, this is just a brief example. It's what we call uh, a C-band radar. C-band simply means it is a 5.5 gigahertz signal. 1 gigahertz, as you might recall, is 10 raised to the power of 9 hertz. And if you like, it is 1,000 megahertz. And so this is a C-band radar ideally suited for recording scattering from clouds or rain or weather. So this is one example of how electromagnetic waves, particularly microwaves, may be of use to us in our daily lives. Yet another example comes from the area of satellites. Now, you might know ISRO in India is very, very active in in making satellites and observing the Earth surface up from the space. Now, the best place to observe Earth is not sit in a jeep or you go cross country and track the geology and the geophysics of the region. Um, Instead, a much better way of observing the Earth is to have a position high up in space and look downwards and see how you can cover a larger area than you would be able to cover with a motor car or a vehicle, just driving cross country. Um, Now, these sensors, these satellites, usually carry a radar of some kind. Now, the radar is actually hidden here. There's this flat plate. Do you see my cursor? I hope you see it. This flat plate here below, you're right. This is actually the antenna. It's a printed antenna, or well, not quite printed. It's a slotted waveguide antenna. You punch holes in waveguides, and out of these holes in the waveguides, your electromagnetic signal comes out. And due to the location of these holes, what happens is you have constructive and destructive interference of the signals creeping out of these little holes. And you design the position of the holes in such a way, as a bit like the my predecessor talked about lattices, crystal lattices. Um, the lattice is designed in such a way that you have constructive interference in the forward direction, and you can have a beam of electromagnetic waves. So, so the wave physics has commonalities in different areas, ranging from, if you like, from band gap to all the way down to simple radio science. Uh, it's a fascinating thing that waves, physics of waves, binds us together. Now, this this radar, this satellite radar, um, works because most of the electromagnetic waves can pierce, can penetrate through the cloud and yet reach the ground and illuminate the ground. And following illumination of the ground, you will have reflections coming back to your antenna, which picks it up and maps the region which you have illuminated. So this is a very, very interesting application, which is going to play a major role in the next few years. Now, this slide is a very generic slide. You know, you see it all over. On the horizontal axis, you see the frequency or the wavelength, whatever you wish, and on the y-axis, you see the attenuation per in decibels per kilometer. And if you were to look at this graph, you'll see that there is very low attenuation um, in the microwave range, right? From 10 to the 8 hertz to 10 to the 10 hertz. And so this window of low attenuation, right, enables the application of diverse devices, which you might like to deploy rather than employ, deploy on the Earth's surface. So this is one picture which you might like to keep in mind as to why we use microwaves so much when it comes to using electromagnetic sensors for observing the Earth. Now, I have great temptation to digress a little. There is a frequency here, and that frequency is about 3 gigahertz, somewhere here. The attenuation is low, most definitely, but at 3 gigahertz, what happens is your water molecules, wherever they might be present, if you were to expose them to 3 gigahertz signal, they absorb a lot of energy, right, due to a resonance effect. And this is how your microwave oven works. Yeah. So whenever you put anything in your microwave oven, right, your food gets hot, your nice, I don't know what you like, to eat, biryani, or ranging from biryani to anything, whichever, something nice, something profusely Indian would be nice, but it should have some water in it, should have water molecules in it. And if you have water molecules in it, yeah, you can heat it up now, because your 3 gigahertz signal would show resonance absorption. And that's why your microwave oven will not heat up your glass, it will heat up the food, but not the glass container in which you might have placed your food to make it hot. Right, that was a mild digression there.
Sorry to
Um,
interrupt you, Professor Madhu. Can you start your presenting again? Something went wrong. You're not seeing the
Sorry,
message.
I, the, I couldn't hear you too well. Could you please repeat yourself?
Yeah, what I'm saying that it looks like we have lost your presentation. So can you share it again? Can you share your screen again?
Oh, have you lost my presentation?
Yeah, something went wrong.
Sir, I think
Oh
it has
dear.
been minimized or some other issues has come because it is coming on a small screen. So if you can please share it again.
Okay, I'll
Share the
do
screen.
so. I'll switch it off. Uh, just a moment, please. All right. Yeah. Uh, okay. This is my screen. I'll go back here and also, I should be completely gone, I guess. And
Yes, sir.
I'll I'll now try to uh, ein Fenster ganzes Bildschirm and I am. Do you see my presentation now?
Yeah, it's coming.
Yes, sir, it's coming.
Now it's okay. You can proceed.
So do I restart? Okay.
No. You can start from the point where you left because
Okay. Right. I hope you can hear me properly. Now, what are the main features which we have to take into account when electromagnetic wave-based sensors are employed? Well, a lot of these electromagnetic waves, as they crisscross through the Earth atmosphere, they are affected. And they're affected by, for example, the atmospheric gases, uh, water vapor, which might be present in the air. And they definitely will be affected by what we call hydrometeors. Hydrometeors is a very fancy word for raindrops, snow crystals, hail, whatever, anything made up of water are known as hydrometeors. Naturally, clouds, and last but not least, the ionosphere. And for completeness, I have included the term multipath effects. And multipath effects are simply sort of electromagnetic waves reflected from different scatterers, regrouping at some stage. This phenomenon carries the name multipath effect. Um, so as a result of all these different media, and all the interactions I briefly alluded to, what happens is your electromagnetic waves will get attenuated as they propagate through a medium, and all electromagnetic waves, they have an amplitude, so they lose their amplitude due to attenuation. But waves not only lose their amplitude, but they also may experience a phase shift. Phase shift in the sense that the amount of electrical distance covered by your electromagnetic wave will depend on the medium through which they are traveling. Depolarization. Now, what is that? Now, that means that the state of polarization
So,
of your
so I'm extremely sorry for disturbing you again. Sir, your presentation has been unpinned. Can you just pin it? There's
wait
one,
a minute.
yeah.
Wait a minute. I think there is somebody named Pooja Kumari. Actually,
Yes,
she.
sir, we have removed her. We have removed her.
Okay.
Just Madhu sir, can you just pin your presentation? It will be on a maximizing screen. If you can see a
spin.
small icon of a pin on your screen.
I see a small icon. So you mean presentation mode?
No. You have to just double
Rajiv
click
sir, you
on.
can do that.
All right, let me try that. I'll try this presentation mode. Is that any better?
No, sir, not yet. Rajiv sir, just pin the presentation.
I sorry, I didn't.
Yeah.
I didn't.
No, it's okay.
You said spin.
No, it's okay.
Pin, sir.
Now it's done, I think. Correct?
Not yet, sir.
Could you please repeat your message? I was
Sir, actually, I am asking for to pin your presentation. There is
oh
one
pin
icon.
to
Yes, sir.
pin it.
Yes.
All right. Okay, I got you now. Let me try this. I'll do the presentation and then pin. Pin. How do I pin it?
The symbol of the pen, if you see.
Symbol. Oh, I think
Yes.
I'll have to go back to the
Sir,
presentation.
right click on that window. If there is a pin is there available, then click on that.
I'll just see. Yeah, I think there's something here. Just a moment. Ausblenden. I'll try the immer noch klicken Sie die Präsentation fortzusetzen oder zu pin. There's a, I saw something to this effect. Pin it. CC. Da, da, da. Oh boy.
Maybe you
Pin.
can restart the sharing. That will fix it.
First you stop the sharing, then reshare it, sir.
Yeah.
Okay. Yeah. Um, all right. Bildschirm wird eingeblendet. And is it better now?
Yes, better,
Yes.
sir.
Yes, sir.
Now
Much
full
better, sir.
screen.
Oh,
F5, sir, on that presentation.
yeah.
Full screen.
Okay. I'm so happy it's worked out. I hope it stays like that. I don't know what I did, but it seems to be working. Right. So, without further ado, let me progress into the talk. Now, what you're seeing here is a radar image um, from a C-band radar, which I showed you in the very beginning. Now, this shows you that on the horizontal axis here, you're seeing the range, and in the vertical axis, you are seeing sorry, you are seeing the height, and your radar is placed at the origin, and the antenna is looking at, is trained to look, you know, towards the cursor here, and then the antenna orientation is changed in elevation. So as a result, your antenna beam, you know, uh, carves out, cuts out a scan through the cloud, and you can see that the cloud has been illuminated by electromagnetic waves, and whatever echoes it generates, you can use those echoes for charting out, for mapping the structure of the rain cloud. Now, such radars are not only used on the ground, but also used in aircraft. And this is a very typical rain, which you might see in the European part of the world. In India, you will see it too. I remember from my Indian days that you will see such rain structures if you start getting closer to the Himalayan range. You will have um, a rain of this type in which you have um, sort of low-level rain, but which lingers on for a long time. And now let's look at this little rain cloud. What is happening here? Now, what is happening here is made visible through another picture of the same cloud. But this picture was generated by looking at the electromagnetic scattering along two polarizations, one the horizontal and the other one the vertical. And then we took the ratio of the two echoes. And engineers, as usual, or physicists, for that sake, they very often use decibels to express numbers which span a large dynamic range. So decibels are a very good way of expressing numbers which vary enormously over your range of interest. And now looking at this quantity known as differential reflectivity, which is the reflectance of electromagnetic waves at two polarizations, and thereupon you take the ratio of the two reflectances, one at horizontal, one at vertical. You take the ratio and you generate a quantity known as differential reflectivity. And differential reflectivity, if you were to study this signature, it reveals fascinating things. For example, what you might be seeing here, these purple colored structures here, they are snow particles, and snow particles scatter more on horizontal polarization than on the vertical polarization. And these snow particles, as they fall from a higher elevation to a lower elevation, they start conglomerating and become snowflakes. And snowflakes do not have a specific shape. They have no favored orientation. So as a result of that, the scattering anisotropy is lost. So snowflakes, once they are generated, they give you low differential reflectivity. And this color, white color here, where my cursor is jumping back and forth, has a 0 dB differential reflectivity. 0 dB means the ratio is 1. The ratio is 1. It means horizontal and vertical scattering are the same magnitude. And yeah, sure enough, so you have landed in this region of snowflakes, and when these snowflakes start to melt, they become, what happens is they collapse, and due to the surface tension, the collapsed snowflake becomes a water droplet, and the water droplet, due to the effect of gravity, becomes like a flat structure. So many people think that raindrop has the shape of wie heißt das? The shape of a pear. Pear. I know the Indian word for it, nashpati. Yeah, something like this. But no, that's what you see in advertisements. The shape of a raindrop is actually like a flattened bun, which you get when you have your soup. You get a little bun, and along with it. So that bunny shape is the shape of a raindrop, and not the tear drop, or the nashpati shape. I hope you know this word, which I know, nashpati. I hope they still call it nashpati. And so that's the shape of. So nashpati is not the shape of raindrop, I hasten to add. It is more like a bun, yeah? And it comes as a bit of a surprise, doesn't it? And that's why you see higher differential reflectivities when the snowflakes are converted into raindrops. And as the raindrops fall, they conglomerate, they become large. And once they become large, they become so large that the surface tension can't hold the raindrop. And the raindrop disintegrates into smaller raindrops. And smaller raindrops are less oblate. They're less oblate than the initial raindrops. And that's why the differential reflectivity falls again. Now, why am I telling you all this? The reason I'm telling you all this is You can use these features from simple physics in order to classify your cloud. And that's what you see here. You can classify your cloud into regions of ice crystals, melting band, region of rain. You may say, why is it of interest to me? The answer is in, in aviation safety, this plays a very, very big role. Now, whether your aircraft flies through rain, or whether it flies through the ice crystals, or whether it flies through the melting band, it has an immense effect. Um, I will show you one picture rather rapidly. Here is, here is a cloud. Again, what you see is um, as a cloud in which you have a radar picture of a cloud. And what do you see here? The cloud, rain cloud, is rising up to 12 kilometers in height, right? And there's no melting band. There is just intense rain with very large raindrops. And these are columns of convection. And as a result, if an aircraft were to fly through this, then the passengers and the pilot would be very, 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 very uncomfortable. As a matter of fact, it would be life-threatening to fly through such a cloud. So the pilots can circumvent this danger by flying around the cloud, providing their radar is able to pick this up. Some of you might recall there was a very tragic air crash of Air France when off the Brazilian coast. And what had happened was the aircraft flew into such a cloud here, like this. This is not the same cloud, I hasten to add. And the electromagnetic signals got attenuated terribly. See, here you're seeing some attenuation effects. And the pilots thought that there is no reflection. So they thought the cloud is safe. And they started to fly through a very dangerous cloud. And the reason it was not scattering back was the electromagnetic waves got absorbed by the water and there were no reflections. And the pilot were not, the chief pilot was having his dinner, sadly, and the young trainee pilot who was flying did not realize that attenuation in radars could be something which he has to take into account. And as a result, due to lack of training, the pilot made an error and he flew through a very, very, very notorious cloud, which got the aircraft down, sadly. So that's an example of radars being used in studying the Earth atmosphere and in aviation safety. I'd like to show you some another picture of weather radar application. Now here, in the middle of the crosswire, I hope you can still hear me. I hope I'm still there. I hope I'm coming through. Would someone please briefly confirm?
Yeah, we can hear you.
Thank you very much indeed. Now here in where you see the middle, the origin of this crosswire, this is the city of Oberpfaffenhofen near Munich. This is, and what you see here are the Alps, where all these skiing, these winter ski resorts are located. You probably see them on the television occasionally, I guess. But I suppose in India, you have much better places in the Himalayas. But these European Alps, they're not very high. No. Compared to the Indian mountains, they're very, very modest. But they're very snow-rich, like the Himalayas, no doubt. And these mountains are beautiful when it comes to snow, when it comes to skiing, when it comes to winter sports, but they're a pain in the neck when it comes to weather prediction. Why? Because you can't tell them apart. The scattering which you're seeing here from the mountains may be confused, may be taken for rain cloud. And this is exactly what's happening here. You see in the picture above, you have a rain cloud, this diffuse cloud system, diffuse colors, and these diffuse colors are superimposed on the mountains, the German Alps, the Austrian Alps. This must be Austria here, and so this is the Austrian and German Alps, and as I said, your rain, as it spans the field in which the Alps are located, the radar operator can't say whether the high scattering is coming from the ground or from the rain. Now, many of you might think it might be easy to subtract, just take away the ground scattering and leave the scattering from rain. It's not that simple. The reason is once the ground gets wet, it starts to behave itself like rain. And so it gets a bit complicated. So we have to figure out a better method of separating rain from mountains, right? Now, how can that happen? Now, you'll see in the picture below, the rain has disappeared, only the mountains are left. In the above picture, both were present. Mind you, the data is from the same situation, but so what did we do? How did we do magic in order to remove the rain, and just make the mountains visible, or vice versa, make rain visible and mountains invisible? Well, the answer is we change the polarization. If you use circular polarization, it turns out that the raindrops are polarization sensitive, and the ground, the mountains are not polarization sensitive. And it turns out that the raindrops are such that you will have no signal, very little signal coming back if you were to illuminate the raindrops with circular polarization. Exactly. So if you were to send out a right circular polarization, and once it hits a raindrop, then what comes back is left circular polarization. So it means you're not getting signal back into the channel in which you sent your signal out. And as a result, you lose your signal from the rain part. And once you lose your signal from the rain part, what's left? You are left with the mountains. So this is a very interesting application of polarization, and so polarization serving the mankind, if you like. I'd like to jump to the last application. I'm getting close to the end of my talk, I guess. This is something known as synthetic aperture radar. I know ISRO in India is highly active in the area. Now, what's happened? What's a synthetic aperture radar? Some of you might know it. You have a very, very ordinary radar, a very cheap, simple radar. Yeah. As a matter of fact, a very homebrew radar will do good, will work. But you can make this cheap, simple radar into a very powerful radar, providing you were to make your radar fly on an aircraft, and you make your radar look towards the ground. So two things: you move your radar and you train your beam towards the ground. Now, what does that do? Now, it simply means you take a simple radar, you move it from one point to the other along the flight path, as if you're taking photograph pictures of the same object from different positions. And by doing this, you can synthesize a very high resolution image. again, it is the periodicity which um, which matters here, and my predecessor um, um, gave a very interesting talk on band gap, and he was alluding to the periodicity time and time again. And the same type of effect is happening here. You are generating a constructive interference by taking coherently measured signals from different positions. And if you add them constructively, you can create a high resolution image with a high um, signal to noise ratio, with a high amplitude. So that is the trick which lies behind synthetic aperture radars. And here is a wonderful picture. There is a synthetic aperture radar. Now this is a picture over the Soviet, not Soviet Union, sorry, it's a picture over Russia, right? um, and the and in this synthetic aperture radar measured scattering from the ground, so you were able to chart out the ground. But there's something else, a part of the ground signal which we were trying to measure in order to figure out the terrain and map uh, the uh, the land surface we were looking. A part of it was blackened out due to attenuation from the clouds here, which you can see. And one of my PhD students, to whom I'm very grateful for his work, Dr. Dunkelmeyer, um, Dr. Dunkelmeyer analyzed this phenomenon, and he predicted how this signal from the synthetic aperture radar um, would lose its strength in illuminating the ground. And he was actually, he went on to use this negative effect in order to get information on the cloud. And so useful was his work that he got the Best Paper Award for IEEE. So this young man was able to predict more than we thought we could get out of the data. So that's an example for research students. If you have data which has very funny effects, yeah, hey, don't throw it away straight away. Don't chuck it in the bin straight away. Maybe you want to take a closer look at it and see why the data is bad. And once you know the data is not corrupt or there's no artifact in it, and if the data is showing some irregular behavior, hey, then you are lucky. You have hit the jackpot. You might find something interesting, and that's exactly what Dr. Dunkelmeyer did. He realized that this blackening is due to a cloud here, and this cloud, he was able to work out properties of the clouds as a result of that. Now, I'll just show you one last picture, and then I'll try to conclude for you, because I think I've lost a lot of time. And now, what's happening here? Here again, you're seeing a cloud. And this cloud, you have a signature of some kind. And now you're wondering, what is this radar signature telling us about the cloud? Now, if you look at the colors say go along this path. You start with blue color, you hit green, and then it becomes red. And if you look at the scale below, yeah, blue is minus 41 degrees, and green is something like minus 35 degrees, and the reddish color is something like 25 degrees. So we're talking of angles. So what is changing here? We're talking about a phase shift. And why is the phase shift occurring as you penetrate into a cloud? The answer is the horizontally polarized waves and vertically polarized waves travel at the two polarizations of light or electromagnetic waves do not propagate with the same velocity. That is to say, the material has different refractive indices along the two polarizations. And as a result of that, what happens is there is the phases of the two waves, horizontally polarized waves and vertically polarized waves, start to drift away from each other. And you start picking up a differential phase. And this differential phase is fascinating. Why is it fascinating? The reason is it will not be affected by attenuation. You are using forward propagation, you're using forward scattering in order to obtain information on the cloud. So using methods such as these, they will be able to improve the application of weather radars to a new level in which the radar operator has not to be worried about attenuation, like the pilots of Air France aeroplane. If they had had a signature of this type, they would have been able to see the cloud all the way through. And this phenomenon is something which I think you will see in the next generation of radars all over the world. Now, I think I'm reaching somewhat towards the end of my talk. I think I've completed my time, taken more time than I should have taken. So I'll abruptly close at this point of time, and I'll be happy to take up any questions or suggestions which you might have. So with these words, I'd like to close the talk and pass the mic back to the conference leadership.
Thank you so much, sir. It was a delight to hear you and see your presentation. Please accept our token of appreciation from Team CIIR.
Thank you. Thank you very much.
Thank you, sir. Now I request Dr. Professor Mainuddin, ex-DRDO scientist professor and former head of Department of Electronics and Communication Engineering, Jamia Millia Islamia, New Delhi, to deliver his talk.
Thank you, ma'am. Good morning. Let me share my presentation first. Am I audible?
Yeah. We can hear you.
Okay.
बताओ एक्स डीआरडीओ साइंटिस्ट प्रेजेंटेशन अपनी प्रेजेंट कर रहा है रिगार्डिंग लेजर एंड इट्स एप्लीकेशन.
I'm audible now?
Yes, yes.
Okay.
We can see your
So,
presentation also.
okay, thank you, sir. First of all, I would like to.
Sir, you're not audible.
I'm thankful to Professor Mehra and Dr. Baral for giving me an opportunity to speak in the National Conference on recent trends in academic research. My topic is latest trends in lasers and its application. So let me see my bandwidth. I'm switching off my video. You know, laser is considered as one of the top technological achievement of 20th century. It is a fantastic tool that plays an important.
Professor Mainuddin, can you unmute yourself? Looks like you are muted.
I don't know. It is getting muted itself. Okay. Now it is clear.
Yes.
Okay. So laser has touched upon almost every sphere of our life. Even in beauty parlor, you will find role of laser. So during last decade, several Nobel Prizes are backed by laser or laser-related technologies. Keeping in view the importance of the light, year 2015 was celebrated as International Year of Light by United Nations. So even in this conference, the keynote talk and invited talk one is related to single photon emitter. So this shows how important is light technology. So the content of my talk uh, is a brief history and evolution of laser, laser fundamental, classification, and finally laser applications with emphasis to defense. I try to make it general so to see the heterogeneity of the audience. So coming to the history of the laser, in 1917, Albert Einstein developed the concept of stimulated emission, which is phenomena used in laser. Later on, Towns and Shallows developed first device based on stimulated emission, which is named as maser. Maser means microwave amplification by stimulated emission of radiation. In 1958, the same researchers suggested that stimulated concept can also be extended to optical region. And it is the Bosov and Prokhorov of Lebedev Institute, Moscow, that extended measure to optical regime, and they won Nobel Prize in 1964 for this work. In 1960, T. Mann demonstrated first ruby laser, and in 1962, a group of researchers worked on semiconductor laser diodes. Another important research that was demonstration of first optical fiber, which opened up a new field of optical fiber communication. Now, high-speed data transmission is a reality. We could enjoy this data speed because of the optical fiber communication. So, laser is nothing but it is an acronym for light amplification by stimulated emission of radiation. Laser is a device that transforms any form of energy into electromagnetic radiation.
Sorry to
The
interrupt you, Professor. Are you
Yes,
changing your slides or is
yeah,
it?
I'm changing my slide. Is it not changing?
Okay, now we can see it. Yeah. Thank you.
Okay, yeah. I just made it in a slideshow mode. Okay, let me take it without slideshow. Uh, laser is a device that transform any form of energy into electromagnetic radiation. The input energy to the laser can be electromagnetic radiation, it can be electrical energy, chemical energy, even it can be mechanical energy. But output of the laser will always be electromagnetic radiation, which includes visible light also. So in next slide shows the basic mechanism behind lasing action. An atom in lower state absorbs photon and then it moves to higher energy state. The atom in excited state can decay spontaneously to lower level and emits a photon. This photon have random direction and phase. But when we use another photon to who compel this excited state atom to come down, then it will emit another photon that will be exactly same as the incoming photon. That is what is known as stimulated emission. And stimulated emission, what makes a laser different from the ordinary light? So let us see what is the uniqueness in laser light. So laser is highly monochromatic light. That means monochromatic means it will emit only single wavelength, and ideally it should emit single wavelength. Then it is highly directional. That means it will not spread much during propagation. And laser light is highly coherent. That means all the waves are in same phase. So in next slide, I try to show another property, that is the brightness of the laser. You can compare from the table that even 1 milliwatt helium neon laser is 100 times brighter than the sun. So this is how bright is laser. As far as the directionality is concerned, low divergence or high beam quality results in highly directional beam that can travel a longer distance and can be focused to a circular spot that will be useful in defense application. So coming to the different kind of lasers, laser covers all the wavelength starting from UV to visible to IR region. Excimer lasers are available in the range of 190 nanometer to 350 nanometer. In visible range, important lasers available are ruby, helium neon, copper vapor, etc. Near infrared lasers have got attention due to its several advantages, which I will cover in subsequent slides. The important near infrared lasers are Nd:YAG, chemical oxygen iodine laser, that is coil, then HFDF, etc. We also have mid-infrared lasers like CO2 laser that emit at 10.6 micron. So different applications require different parameters, lasing parameters. The important parameters of lasers include wavelength, line width, beam quality, power, etc. So if we are looking for a laser for optical fiber communication, then I'm interested in a wavelength of, let us say, 1.55 micron, which is a loss wavelength in optical fiber. Similarly, if I want to use a laser for industrial purpose, then I'm interested in a power level of around 1 to 10 kilowatt kind of things. And for defense application, power requirement will be hundreds of kilowatt. So there is no laser which can fulfill all the needs. So different laser technologies have been developed over the years. So coming to the classification of the lasers, we can classify laser in a number of ways. One of the way is based on the lasing material. We can have solid state laser, we can have liquid laser, and we can have gas laser. Solid state lasers are the lasers in which lasing medium is solid, like ruby laser, Nd:YAG laser, ND glass laser. But in solid state laser, due to the poor heat dissipation, sometimes solid rod gets damaged. So people are interested in liquid laser because of this. In circulation mode, we can have better heat dissipation capabilities of the liquid medium. So dye lasers are known since long, but nowadays recent trend is people are developing different types of liquid lasers for different high power application. In gas laser, different gas lasers are CO2 laser, CO laser, nitrogen laser, copper vapor laser, etc. Similarly, we have chemical lasers. Chemical lasers use chemical energy for population inversion and like that. We can also classify laser based on the power level. As far as the power level is concerned, then any laser with 0.3 microwatt comes in the class 1 laser. And this kind of lasers are used in CD player and scanner. Class 2 laser includes the power level of 1 milliwatt, and these lasers are normally being used for alignment purposes. Class 3A lasers have a power level of 5 milliwatt, and they are hazardous only for intra-beam viewing. Similarly, we have class 3B lasers. They are moderate power lasers of around 500 milliwatt. Any laser which is greater or equal to 500 milliwatt is termed as high power laser, and they have if you look into the lasers directly or indirectly, they are hazardous to you. So when you are handling high power lasers, you should be very careful. Handling of, normally people keep high power laser beam height above the human height for sake of safety purposes. So now let me come to the another part of the talk, that is application of the laser. So I'll cover laser application in industry, in medicine, in test and measurement equipments or scientific experiments, laser in communication, and finally it is laser in defense application. As far as the industrial application are concerned, The evolution of industrial laser is shown in this slide. CO2 laser have been known to us since long, and other industrial lasers are like ND-YAG, excimer lasers are also popular. For industrial applications, typically 1 to 10 kilowatt power levels are required. Uh, then let me go to the next slide, which will show the different lasers available for industrial application along with their power levels. If you look carefully into this slide, you will find there is a new entrant like fiber laser, which has been used for industrial application. Nowadays, 10 kilowatt single mode fiber lasers are reality, which are very much useful in industrial application. Similarly, chemical oxygen iodine laser is also very popular for industrial application. We'll see some of the application of coil in a subsequent slide. So laser can be used in cutting of the metal or welding of the metal. As far as the laser cutting is concerned, previous methods of punch press require the punch press kind of things provide you less precision, and there are safety issues in manual operation. So it is the laser which will give you very fine finish. You can cut the material using laser beam. So how does it work? The laser beam is focused onto the material, and then sufficient power density is generated to melt the material. The molten material will reflect back your laser beam. Then how to avoid this problem? Then what is done? Then assisted nitrogen gas is normally used to remove the molten material from the surface. So with the help of laser, you can achieve excellent accuracy and precision. And it is safe to operate because you are operating a machine, laser based machine remotely, and there is no direct human contact, so it will be safe to operate. Next application, it is very interesting application which is demonstrated by Japanese. They use laser for remote dismantling and disposal of obsolete nuclear reactor. So in 1998, Japanese have used 10 kilowatt chemical oxygen iodine laser. Normally we call it coil. Coil is nothing but it is chemical oxygen iodine laser. And that 10 kilowatt laser is transported to the nuclear site with the help of an optical fiber. And now it is the robotic arm that dismantle the obsolete nuclear reactor for its safe disposal. So this is one of the application which is used to cut the metal. Next application is laser welding. So welding of different metals can be done with the help of laser. You will find a very precise welding, and you will find its application in a lot of automobile industries. Laser has find application in the medicine. So lasers are used in surgery. For soft tissues clinical application, CO2, ND-YAG, and diode lasers are being used. Whereas for hard tissue clinical application, erbium lasers are the best suited choice. These are used for removal of impacted tooth under bone or bone grafting, etc. All of you are aware of LASIK. LASIK is nothing but it is a laser based equipment which will give you freedom from cataract problems. So how does it work? No, the tiny flap of outer cornea is folded back, and then laser removes the tissue from the remaining cornea to change its shape, and then finally flap of outer cornea is reattached. So what kind of laser is useful for it? Normally lower wavelength laser is preferred, and lower level wavelength means we are interested in UV range. So excimer laser is the best suited laser for this application due to several advantages. Now next application is laser is used for tattoo removal. What is done in this case? Laser breaks the pigments in tattoo into tiny particles, and then it is the body immune system then attack and destroy them. And important lasers which are being used in this application are ruby, Nd:YAG, and alexandrite. So as far as the laser application in scientific experiments is concerned, laser has find a number of application. I'll show you one of the application, that is gas concentration measurement of any species. I'll take an example of chemical oxygen iodine laser. See, chemical oxygen iodine laser is a laser in which iodine is a lasing medium. It's a high flowing gas medium laser in which iodine is the lasing medium. Both lake and axis of the iodine will degrade laser performance. Then there is a need to precisely measure iodine flow rates or iodine concentration in the laser cavity. But problem is that since it involves high speed gases, you cannot put external sensor inside the flow. So you have to have a method which is non-contact type. So in this case, we can use optical technique. You know, iodine molecule has a peak absorption at 499 nanometer. So in this setup, a laser beam is passed through the medium and signal is detected at the other end. In case of there is no iodine, you will get a signal. Once iodine starts flowing through the line, then molecules will absorb the signal and you will get a dip in the detector. So by using Beer-Lambert law, you can estimate the number density or concentration of the iodine molecule. This is how we can use optical technique for gas concentration measurement. This is one of the system which I developed during my tenure at DRDO for chemical oxygen iodine laser. So another application is if you can use laser for if you visit any mall or grocery shop, you will find laser based barcode scanner which are used for inventory and pricing information. It is possible to quickly obtain data on both at the same time. Lasers are also used, in another application like roughness testing of the surface. So roughness is an imperfection on the surface of the material. One can use backscatter signal, and then you can find estimated. You can estimate the roughness number of the surface. You have find speed measurement device with the police person. So sometimes they can use Doppler shift based laser speed measurement system, and they will find over speeding vehicle. So this is also one of the application of laser based device. Now coming to the communication field. Nowadays it is possible to transmit signal with the speed of gigabit per second. That is commonly available nowadays. So this is possible because of the advent of optical communication. Optical fiber communication offers a lot of advantage over the RF communication, like it has very high bandwidth. It cannot be intercepted by unauthorized person easily. It does not have any EMI EMC problem. And however, installation of optical fiber cable is tedious and costly affair. The first commercial installation of optical fiber system was completed in 1977 by Bell Lab. In this case, how does it work? Laser acts as a carrier of my signal. My signal can be audio or video or can be text. So it is modulated and transmitted over the fiber, and then it is demodulated at the other end. The important wavelengths which are useful for communication purposes, for optical fiber communication purposes, is 1.55 micrometer. This is the wavelength which offers minimum attenuation in optical fiber. Similarly, we can use 1.310 micrometer wavelength, which exhibit low dispersion. So this is how laser can be used in optical communication. You have find application of laser in laser printer to find a good quality print. I will not spend much time here. And similarly, you have an application of laser in CD players. CD-ROM uses a semiconductor laser to read the binary information from the disk, and without laser, there will be no CD player. Now, coming to my last part of the talk, that is defense application of laser. In defense, laser can be used as a tool or as a weapon. So if you use laser as a tool, you can have an application like laser rangefinder or target designator or many other applications like that. Or you can use laser as a countermeasure for countermeasure purposes. So as a weapon, you can use laser as a directed energy weapon. For laser to be used as a DEW, it should be able to produce very high power so that you can destroy the target. It should have a very large operation time so that sufficient power can be reached to the target. It should have high influence on the target, and in battlefield scenario, electrical power is a problem. You cannot find electrical power easily there. So you should have a laser system that should operate with minimum electrical power requirement. What is the solution for DEW lasers? You have an option like HFDF lasers. You can use chemical oxygen iodine laser, or you can use CO2 GDL. All four lasers already showed their capability to use as a DEW application. Because of the reason that these lasers does not operate on electricity, the only electricity requirement is just for supply of the sensors and actuators. Lasing action is due to the either mechanical energy or it is the chemical energy. As far as the HF and DF laser is concerned, these lasers are highly toxic, so people don't use these kind of lasers nowadays. CO2 GDL is a very bulky system. It operates at a very high temperature and high pressure, and it is a noisy system. So that is why CO2 GDL is now obsolete technology. So the only if you are looking for a megawatt class kind of laser, it is the chemical oxygen iodine laser. Recent trend is to use coil for megawatt class of lasers. Lot of research has been done, and people are still doing lot many things to realize a system which can qualify for high power laser category. Other lasers are also available, which are also competitor for these technologies like solid state lasers and fiber lasers. But solid state laser and fiber lasers these lasers are not able to exceed power level more than 100 kilowatt by combining several modules. Still, lot of research is being done in this field to get megawatt class kind of lasers for defense application. So let me start with the laser as a tool in defense. One of the application I have shown here is laser target designator. What is done in this case? You have heard the word laser guided bomb or laser guided missile. How does it work? What is done then? The target is shined, you shine the target with the laser. Now your missile or your laser guided bomb will be following this, this laser, and now it will be destroying the target. So you have already seen or heard about the laser guided bomb or laser guided missile. They work in the same way. You can use same laser to countermeasure this kind of threat. What is done if you are detecting laser threat? I'll go to back to this slide again. If you are detecting any laser threat by somehow by using some detector or laser threat warner, then how you can deceive the guided bomb. How will you do it? Either you can generate high power laser and you can transmit back to the this weapon side, then its detector will get saturated. This is one of the way you can deceive. You can use countermeasure. Or another way is you can generate a smoke screen so that target the weapon can be deceived. This is how people are using laser for pinpoint destruction of the target and its deception. As a weapon, laser can be used as a weapon. It is a very old technology. Light was used as a weapon even in 212 BC. Archimedes used sunlight to destroy a boat. So the same experiment was reproduced by MIT in 2009. What they did, they collected sunlight, and the light is reflected from a couple of mirrors, and they demonstrated that boat is destroyed by the sunlight. So this is how the laser was used in old days to destroy the target. Laser. So nowadays, people are using laser as a weapon. Why do we use laser as a weapon? We have, number of advantages. One of the advantages is this, that laser operates at the speed of light. That means enemy will not have, any reaction time to this weapon. So that's why this is one of the advantages of DEW. Another advantage is that, see, if you fire at laser, whether it hits the target or it does not hit the target, your millions of dollars have gone. So, but in case of laser-based weapon, laser equipment is always with you. You can you can do multiple firing, and the multiple firing with the cost effectiveness is possible with the DW based equipment. And one more important advantage of directed energy weapon is that it has zero gravity effect. So these kind of system can be employed in space kind of application. So next slide, the previous speaker showed one of the slide in which he showed atmospheric transmission window for microwave. But we are interested in, transmission window of atmosphere for optical signals. If you look at this graph, you will find that 0.8 to 1.5 micrometer is the wavelength at which you will get around 70% of atmospheric transmission. And lower the wavelength, more will be the photon energy. E is equal to SC by lambda. So lower wavelength will have better energy per photon, and lower wavelength will also have better laser material interaction, and it will have a smaller optic size, and fiber compatibility is also there. So because of all these advantages, people are working on developing DEW lasers in this range, only 0.8 to 1.5 micron. So this is the justification how people are working or interested in this range only. So in next slide, I will try to show you some of the international, scenario for using laser as a weapon. In order to fulfill demand for DEW application, latest trends in source selection is fiber and liquid lasers. For tactical application like engagement of UAV up to 8 to 10 kilometer with the power level of 100 kilowatt. So 100 kilowatt power has already been demonstrated by these two lasers like fiber and liquid laser. But if we are looking for destroying the missile at enemy territory during its boost phase itself, then we are looking for strategic applications in which I need a megawatt class of laser which can destroy the target with the range of, let us say, 150 to 500 kilometer range. And for this kind of power level, we have only one option, that is chemical oxygen iodine laser. Other lasers of megawatt class were also developed, but due to the toxicity of the chemicals which are being used in that those lasers, people did not continue that research that I discussed in my previous part of the talk. So let me see what kind of laser system have already been demonstrated by international community. Yes, one of the system is airborne laser, ABL. ABL, this laser has been demonstrated by US in 2010. What they did, they assembled 200 kilowatt coil modules. 6 modules were combined together, and they are mounted on a Boeing 747 aircraft. and aim was to destroy the missile during their boost phase. So they successfully demonstrated, destruction of the target at 150 kilometer. The another important laser that is, reported in the literature, that is advanced tactical lasers, ATL. ATL also utilizes coil chemical oxygen iodide laser of around 200 kilowatt, and they mounted this laser on C-130 aircraft, and successfully this laser demonstrated destruction of the target at around 8 kilometer. So if you look at international military scenario, coil is the option which is already reached to a stage that different weapon systems have been demonstrated, and different countries are working towards development of this laser. However, since the involvement of chemicals in this laser, it is difficult to handle several chemicals, but they are not as dangerous as HFDF. But still, people want to develop a laser system based on solid state technology or fiber. So a lot of work is being done in fiber lasers or solid state lasers. What they are trying to do, they are trying to develop a module of, let us say, 10 kilowatt modules or 20 kilowatt modules or 50 kilowatt modules. Then they will try to do beam combining so that they can reach up to the level of megawatt class of laser. But still, lot of work is to be done. It is under development stage. So future is for solid state and ABL, but for megawatt class of laser till date, coil is the only option. So to conclude my talk, I can say that laser have touched upon every sphere of our life, starting from barcode scanner to medical to industry and defense applications. So different lasers have used different platform for diverse missions. And with this, let me say thank you for patiently listening. Thank you so much.
Thank you so much, sir. May I request Rajiv Kumar Srivastava, sir, session chair, to deliver the vote of thanks to our speakers?
Okay, so first of all, I want to thank Professor Madhu Chandra for his talk on usage of radars. Especially, he explained very well how this can be used to understand the cloud composition, and which can be very helpful for aviation safety. And also, he explained very well the volumetric measurements and synthetic aperture radar. Thanks a lot for this valuable presentation. Then I want to thank Professor Manuddin for his very interesting talk on lasers. And he very nicely explained the concepts of laser and its classification. And then the best part was its application. I mean, we were all surprised to see that the laser application is applicable to our for a small task of daily lives, and also for the complex defense system. And that was really interesting. So thanks a lot, Professor Manuddin.
Thank you, sir.
Thank you, Professor Manuddin. Thank you.
Thank you, sir. Thank you so much, sir.
Thank you, sir. Please, Manuddin, sir, please accept a token of appreciation from Team CIIR.
Thanks a lot.
I would like to request Mehra, sir, to please conclude this conference.
Yeah, it has been a very nice experience. We organized this particular conference for the first time. I'm thankful to all the eminent speakers. I'm sure that all the participants have been enlightened. I myself have learned many things. New things were discussed. So today's speaker, Madhuji, Manuddin, and Amitava, all are expert in their field, and we need their cooperation in future as well, their support also in future as well. And I congratulate my team who are monitoring Vaishali and her team, who are monitoring the whole system. There was
Thank you, sir.
absolutely no disturbance, and whenever there was some issue of presentation, Vaishali was able to solve it. So thank you very much, Vaishali, and thank you
Thank you, sir. Thank you, sir.
all the good wishes. And I hope the blessings of our eminent speakers will remain forever. Thank you very much. Thank you.
Thank you, sir. Ruth, sir, if you want to add something to it.
Rajiv ji, thank you for chairing such a wonderful session and summarizing it in a very nice way.
Thank you, sir. Thank you.
Ruth, sir, if you want to add something.
Dr. Kamal Kishan Sharma has been throughout the meeting, and I will like him to share his expressions about this conference. I'll be delighted.
All right. So with this, we come to an end of the conference. We hope that you all had an insightful session in these 2 days. And on the behalf of the team CIR, I would like to thank all the speakers for giving your time and delivering such an insightful and informative session. Thank you everyone for joining us and being a patient hearing and making this conference such a big success. At the end, all the participants who will be presenting their papers, I would like to request all of them to join their respective rooms. Thank you, everyone. Thank you so much.
Ma'am, how we can get the room?
Your links must have been sent to your email ID, sir.
Thank you.
Okay. Thank you, sir. Thank you so much, everyone.
Excuse me, ma'am. Which link do we have to join for paper presentation? Hello. Yes, sir.
You get the mail for the
I didn't receive any mail, but ma'am has right now sent me the link.
A very good morning to all of you. Hi, I am Manshi. I welcome you all in the paper presentation session at room 4 at day 2 of the conference, Recent Trends in Academic Research. Firstly, I would like to brief all of you regarding rules of this session. So each presenter will have to spend 10 minutes to present their paper, where the presenter should focus on results and conclusions of their paper, keeping in mind that the introduction part should be a little brief. So after 7 minutes, the presenter will be notified so that remaining presentation is wrapped up in the remaining 3 minutes. As the name of the presenter is announced, you have to unmute yourself and present your screen. Every other participant should keep themselves at mute for maintaining the decorum of this room. So I hope all of you must have noted the order in which you will have to present your paper. So in order to begin, I would like to begin with the first presenter, who is Manpreet Kaur, and she will be presenting the paper of the title, Simultaneous Estimation of Tramadol and Atoroxib by UV Spectrophotometer and RT-HPLC. Hi Manpreet, if you are there, please unmute yourself and present your screen and start the paper presentation.
Hello. Hello, good afternoon all. I'm audible?
Yes, Manpreet. A very good afternoon. You are audible.
Okay. Good afternoon all. I'm Manpreet Kaur, research scholar from RIMT University, Mandi Gobindgarh, Punjab. Is it visible? Is it visible?
No, Manpreet, your screen is not visible. Kindly retry presenting your screen.
Is it visible?
No, sorry, Manpreet, it's not visible yet. Now it's visible.
Okay. Okay. So my topic, that is the simultaneous estimation of tramadol HCl and atorecoxib by UV spectrophotometer in RP-HCl. So there are a table of contents, that is introduction first of all, then pre-formulation studies, then FTIR analysis, Then simultaneous estimations of tramadol, HCl, and etheric oxide by UV spectrophotometer. That is, then after that there is a method validation, and then same simultaneous estimation of tramadol and etheric oxide by HPLC, and then again method validation, and then conclusion. So first of all, there is some about work introduction. That is, this works that is totally relates the development of an analytical method to simultaneous estimation of two drugs. These two drugs, that is the tramadol HCl and etheric oxide, these are in combination formulation. The purposed method, mainly it is based on, that is UV spectrophotometer
Hi,
and HPLC.
Manpreet, sorry to interrupt, but can you please zoom in your slides because your slides are not visible.
Okay.
Okay.
Is it okay, ma'am?
Yeah, okay, it's fine, it's fine. You can present it. Yeah.
Okay. So there are two drugs, that is the tramadol HCl and etheric oxide. There is in the combination formulation. So mainly there are two instruments we use, that is the UV spectrophotometer and HPLC. So there is one technique we use, that is absorption extraction technique, that is used for the simultaneous determination using UV spectrophotometer. There is the use of HPLC, there is separation that is made from C18 column we use. That is 20 mm phosphate buffer we use, and the mobile phase there is a flow rate that is 1.02 ml per minute. So there are parameters are validated, different parameters which we use for validation, and like accuracy, precision, repeatability. So this method mainly it is a fast and precise. So first of all, introduction. In introduction, there is a tramadol, first of all. So tramadol, that is the dimethylaminomethyl and methoxyphenyl cyclohexane. It is a midway acting manufacturing. Mainly the tramadol, that is a narcotic pain reliever, and serotonin norepinephrine reuptake inhibitor. So mainly, primarily, it firstly to identify with the codeine and morphine. So its mechanism is a dual. That is serotonin, noradrenaline, reuptake, and the second one, that is the tramadol. It contributes to analgesia, that is by binding of microopioid receptor. So tramadol, mainly it is available of various agony types, that is neuropathic treatment and post-operative treatment also we use, and especially in the lower back pain, we use the tramadol here. And pain related to the labor, that is osteoarthritis and fibromyalgia, and malignant growth also for cancer. And where is etheric oxide? Etheric oxide is methylpyridine, that is methyl sulfophenylpyridine, that is COX-2 inhibitor mainly. So current therapeutic science, that is the rheumatoid joint inflammation. In this we use etheric oxide, then osteoarthritis and ankylosing spondylitis, and on some low back agony, that is intense pain and gout form. So in COX-2 particular inhibitor, there is an activity of enzyme, that is a cyclooxygenase compounds, that is the production of prostaglandins from arachidonic acid. But individual drugs we are reported, that is it show less analgesic effect. So when we use in the combination, that is the tramadol and etheric oxide, that its effect is very much effect. It show better treatment. So better treatment opinion have. And there is some like tramadol and etheric oxide. These are some structures of tramadol and etheric oxide. So there are several clinical studies has been shown in the combination of tramadol and etheric oxide, and analgesic effect as usual, an individual drug with the less side effect. But there is no analytical method is available for qualitative and quantitative determination. But here we need, that is the qualitative and quantitative determination for individual drug. That is in the both combinations also. So there is, we use multi-component analysis of drugs, which includes different type of spectrophotometers we use, and then chromatography and electrophoresis. So in UV spectrophotometric methods for simultaneous determination of drugs, it's highlighted in this work actually. So next is, there is firstly, it's a pre-formulation study. So in pre-formulation studies mainly, it's a protocol for development of all safe and effective and stable dosage form So obtained drug sample, it mainly identified for various parameters like color, then odor, nature, and its melting point also. And there is main thing, that is the solubility. The tramadol and etorecoxib, it may be soluble in water, methanol, ethanol, as well as chloroform. So its partition coefficient also. Then first of all, we done UV estimation. In UV estimation, UV visible spectrophotometer, we used Marju 1800 Japan with 10 mm matched quad cells in analytical balance and pre-validated volumetric flask and pipettes, etc., and whatever we use for the further dispersion. Firstly, it's a reagents and standard solution. So in tramadol and toricoxib, this is firstly obtained from this pharma private Hyderabad, and then it's a thermoscientific, we use ethanol. Firstly, we prepare the stock solution. From the standard stock solution, we take 1000 microgram per ml. So then pipette out 20 ml from that, and then 100 ml volumetric flask, and volume was made up to mark with methanol. So first of all, we made the stock solution from this. Then analytical wavelength select, then overlay spectrum, which is used to decide the isoabsorptive or isobestic point for analysis. So there are two wavelengths, that is 236 nanometer and 282 nanometer were selected. So we select two wavelengths. Then selection of analytical concentrated ranges. There are different concentrated ranges we select here. That is the range from pound, that is 2 to 14 microgram per ml for etorecoxib, and tramadol, that is found to 20 to 160 microgram per ml. And the absorbance we recorded, which we use, that is the 282 nanometer, which is isobestic point. So we use here, that is the one method, that is absorbance spectration method. So for this toricoxib and tramadol HCl, we firstly utilize the isoactive point, that is the 282 nanometer. And there is the isobestic point for further absorbance also. And then isobestic point 282 nanometer, it will calculate it using absorbance factor, which is the average of the absorbance of different concentrations we use here. So in absorbance mixture of the binary mixture, that is the 282 nanometer we take, and then absorbance factor of pure tramadol, that is the from 272 nanometer, we calculate, that is the 0.58. So after that, after the UV estimation, there are results and discussions for this upon calculation of concentration of individual drug. First of all, simultaneous estimation method. So denominator value is found to be the negative, that is the negative 0.0004. And the another method we opted, that is for the subtraction method. Then on calculating by this method, the HCl of tramadol HCl and toricoxib, they are both of the isobestic point, and the calculation percentage recovery, that is at 282 nanometer, it provides accurate and satisfactory results. And here the graph is the whole linear graph we show of the tramadol and toricoxib while using this method. So there are some ranges, that is the linearity range, that is the only a satisfactory result which show accurately as compared to the standard. That is the linearity range. That's the regression equation we use, and there is an intercept, and then slope and correlation. So correlation is always 0.009. So as according to this, the correlation is same. Then HPLC estimation. So there is also a results of like further robustness and repeatability also. So in this, these results are repeatability, like intraday results, so have 100% like accurate and reliable results we show. Then HPLC, in HPLC estimation, there is a which we use HPLC, that is SPD 10AV UV visible detector we use here, and auto sampler HPLC we use, and LC solution software in analytical balance we use. In this tramadol and toricoxib, they are obtained from SLR Pharma Private Limited, and like these all we take from different industries. In chromatographic method, the isocratic mobile phase, it consists of 20 ml phosphate buffer, that is pH is 4.6. So firstly, we prepare the standard stock solution for that. Firstly, we prepare the black solution, that is dilute, was filtered through 0.22 micromillipore membrane filters, and it injected in HPLC system. So in standard stock solution we prepare, in this 10 mg of tramadol and 10 mg of etorecoxib drugs, they are the drug was accurately weighed in separate put about 10 ml of volumetric flask containing 5 ml of dilute sphere. The solution was sonicated for 10 minutes and volume was adjusted to up to mark of diluents. So in this sample solution we prepared, in this tramadol and toric oxide was prepared from our stock solution and filtered through 0.22 micro millipore membrane filters. So in this method, the optimization, mainly HPLC method, it will be it's all done by the designing, that is expert software, in which the development of method, that is the box Denkin design was employed. So in this method,
Manpreet, you have 2 more minutes left to wrap up your presentation.
Okay, sure, ma'am. So in this, we take one design that we use, that is the box Denkum design we use. So area of tramadol and hold retention time, that is the accurate procedures. Like in this, there is use precision and intermediate precisions, and different there is the results, that is percentage recovery level, concentrated added, which we concentrated in which that is added, then percentage recovery and RST. We find out with this. In studied parameter, mainly the change in wavelength. So the results for robustness study, it indicated that the small change in the conditions. So there, firstly we prepare it from the gel preparation. We take place gel preparation. So accurately we take a prepared gel equivalent, that is the tramadol and etoric oxide. So it's a whole procedure of the gel assay, that is a volumetric flask. And from this, the readings is a claimed concentration like 10 and etoric oxides 3. And observed concentration is the same as in an accurate form. So at last, I concluded in this, the combination drugs, mainly products, it's occupy a time-honored and important role in the therapeutics. So when rationally formulated, the fixed combination drugs may produce some greater convenience and lower cost. And this method mainly, it is a very much accurate method, and it showed not very much analgesic effects, like not a high level of this. And in present is the analytical method for qualitative and quantitative analysis combination. Like in a whole research work, we didn't find any type of qualitative and quantitative research method for this. And the combination of tramadol HCl and etoric oxide by UV spectrophotometer and HPLC was developed. So this method is fast, accurate, precise, insensitive, and it can be employed for routine quality control of the combination of both drugs in formulation. Thank you.
Thank you, Manpreet. Thank you very much for a wonderful presentation. So the next presenter that we have is Mr. Arvind Kumar Chaudhary, who will be presenting the paper entitled Analytical Evaluation of Ellagic Acid Terminalia Shibula Extract by RPHPLC. So I would request Mr. Arvind Kumar to unmute himself and present the screen.
Good afternoon.
Manpreet, stop the presentation mode.
Good afternoon, ma'am. This is Dr. Arvind Kumar from Vinayaka Mission Medical College.
Good afternoon, sir.
And today is my presentation is all about one evaluation of a drug quantity from a herbal sources, actually.
Okay. Sir, do you want to present your screen? Do you have a presentation to show?
Yeah, ma'am.
Yeah, okay.
I think someone is already presenting.
Yes. Manpreet, can you please switch off the presentation mode? Manpreet, can you hear me?
Yeah. Okay.
Yes, you can start the presentation now.
Yes, ma'am. Hi, this is Dr. Arvind Kumar. Actually, I'm assistant professor in Government Medical College, Erode, Tamil Nadu, as well as I'm doing my PhD of in Vinayaka Mission University, Vinayaka Mission Medical College, and here. And the method why we have used, as I told you in my introduction itself, it's a reverse HPLC, and result and discussion I'll discuss with it. So, alginic acid is kinds of work as an antioxidant and anti-mutagenic or anti-cancer property. It has also got some kinds of spasmodic activity. It's also used for the treatment of diabetic in term of Ayurveda. It's a kinds of source is the plant which is called terminal chabula. We also know that plant in a local name Hartika or maybe Triphala. There is some Himalaya product also there with the Triphala, and it has been used from the primitive age for the many diseases like a colon, cancerous or ulcer diseases, gastric or esophageal diseases, or maybe some kind of skin and pancreatic diseases as well. So it has basically used now in Ayurveda. I cannot say it has been adapted in pharmaceutical preparation. Slowly, many preparation is coming up in a pharmaceutical as well. I have just selected the particular part of the plant is the fruit pulp, which has got advanced amount of the azelaic acid and chabulic acid, chebujasic acid. So the basically how this particular azelaic acid is acting to by preventing the cancer is like, it has got a cancer scavenging property which inactivate by inhibiting the cancer causing chemicals, or it's inhibit their growth, or it's also has a chemical cause which in a bacteria, some certain cancer which is because of the inflammation or infection due to the bacteria as well. So they also have deactivating property or inhibiting property actually. And additionally, they are also preventing the carcinogens, particularly which is a DNA carrying molecules, which are, or we can call it as oncogens as well. Sometime it's and it's reduced the incident of the cancer in culturing some of the lower primate. It has been shown that it can reduce the cancer growth cells which have, and like the chemically this molecule is, somehow it's looks like a glucose molecules, like very much density, melting point, and all those I have shown that it is soluble in a methanol and slightly soluble in a water as well. Stability under the normal condition, it's very fine. It's not getting any kinds of oxidizing or any kinds of rusting property. It has the chemical and physiological property in a human as well as in the lower primate. It has been shown. My intention of this research was to HPLC method for screening the alginic acid present in a terminal level of food pulp formulation. So I have used the method by using the chemical, getting the chemical from the Sigma starch, Aldrich, and from US. The brand name and product name I have shown here. A terminal level product which I have got from 500 grams. 5 pack of bottle which I got from the Cloud Trail. Amazon is selling it, and we have tasted the product as well. That is the Hyderabad associated delivery agent they have given to us, and we use the chromatography or HPLC consisting the Samanju prominence injector of 20 micro liter fixed loop separation was by Fermex, which is C18 ODS columns which contain it, and it has in a normal room temperature it is length of around 250 mm to the 4.6 mm. IDA is around 5 micrometers. So we have tried to find out what is the strength of the alginic acid found in by chromatographical conditions by determining the performance by using the C18 reverse phase column under the room temperature and using the injector volume of 20 micron fixed loop at the flow of the 1 ml per minutes. And the mobile phase which composite was optimized with the solution of acetonitrile and water containing 0.01% volume and orthophosphoric acid having the ratio of 80:20 at the detection wavelength of 270 nm. We found that alginic acid is a fixed chromatographic condition was kept from the evaluation and was used by using the HPLC method. So there was no any oxidation. We have tried to prepare the mobile phase, and I think I may not go for the deep of the methodology. I just want to say the mobile phase was prepared by using the 1 ml of orthophosphoric acid and dissolved into the 1000 ml of 1000 ml of cube of waters, and filter was discarded by using the sonic acid followed by the mixed with the acetonitrile and buffer solution by 80:20, and standard phase as similar, like we have a 10 milligram of fresh alginic acid taken into the 10 ml of flask and dissolved into the 5 ml of methanol, and we have prepared a solution of and quantified the solution of 0.25 ml, 0.4 ml, 0.6.
Yeah, so I will now click on the start button. This is our home page. Yeah, so here the user will be given 4 options: alphabet, animals, flowers, and vehicle. So now I will click on animal. As I click on animals button, it will start in camera. Yeah, so here you can see the website that we have developed on which we can scan the object. So this is the website Smart Learning. This is also we have developed here. So we have 4 menus here. So for now we want to scan animal. So now we will click on animal. Here we will select any one of the animals. Suppose we select a horse. A horse has been completely created a 3D object of the horse. So we can view this horse from any angle, which will create an interest in students. Yeah. So we can move more closer to it. You can see. So this creates much more interest in the students. Like we can go for another. Yeah, a dog. So we can see a dog which has come out of the screen. We can zoom into it. Similarly, we have done for others, like for flowers we have done. So for that we need to go back. We need to select flowers, and then we can select any of the flower, like daisy. Yeah. We can get a back view of this flower also. Similarly, we can see some another flower, rose. Yeah, see the rose. We have also added some information like rose is the king of flowers. Like it will give some knowledge about the rose to the small kids. Similarly, we have done for vehicles. Let's see a truck. Yeah. Okay, I need to go back. Then vehicles. Yeah. So a 3D model of the truck has been created. We can zoom into it. We can see it from much more distance. And not only this, we have added some music like it will give an interest. So like if I am scanning for A for apple, so now you can add.
An apple a day keeps Dr. away. Apples are a good source of vitamin C and fiber. Apples support a healthy immune system. One medium apple has about 100 calories.
So this was all about our project. Yeah. So I will not stop sharing.
Is your presentation over?
Yeah, just one
No,
second. We would like to come. Yeah. So we would, Abhishek, are you presenting?
Yeah, just.
Yeah. Yeah, so we would like to conclude this session. So this is our conclusion. So our app, Smart Learning, has provided an interactive interface that enhances learning for the kids, allowing today's generation of students for learning faster, learning better, and retain the knowledge longer than ever before. So that's why AI technology has led to better understanding of human concepts and natural learning. So this was the conclusion, and now we will just show the paper, IEEE paper that we have created. Yeah. So this is the research paper we have written, which describes in detail of our study of other research papers and the technologies used and how we have developed this project. So we would like to express our deep gratitude towards our guide, Professor Arsarange ma'am, and Dr. Milind Kulkarni sir, the head of multidisciplinary engineering in Vishwakarma Institute of Technology, for their patient guidance and enthusiastic encouragement for this work, research work. We would also like to thank National Conference on Recent Trend and Academic Research for giving us this opportunity for presenting our paper. Thank you.
Thank you. Thank you, sir.
Thank you, sir. Are there any questions? Any questions regarding this paper? Okay. So we'll proceed to next presenter. That is Aryan Shinde. Aryan Shinde, are you here?
Yeah, I'm here. Hello.
Yeah, okay. You can proceed now, Aryan.
Sure. Can I share my PPT?
Yeah, sure. Of course you can share.
Okay. Okay, sure. Is my screen visible?
Yes, your screen is visible.
Okay, so I'll start with this. So for this project and for this conference, what we have tried to make is we have firstly got in the domain of education, and in this pandemic time, what we have faced currently is it is very difficult to manage our notes and all the PDFs that we get from our teachers and from the notes that are basically in online format. So it becomes quite hectic to handle everything and actually manage every note, every PDF, every study material that we get from our teachers and our faculty members. And it becomes quite tedious to actually manually manage it. So what we have done is we have created a website where we actually can upload our notes such that when it is accidentally deleted from our local machine, I can still download it from my account. And also we have added a list section where we can add the deadlines of it. Like we have many deadlines in the future. Suppose I have some vivas or assignments to do or lectures to attend, so I can add that in the list. I'll show you further the demo, but this is what Studify is. We have kept this name as Studify, and this is what actually it does. And so the unseen part. So for this web app, we have used Python as our primary language, but Django as our backend server, the framework, and a SQL database 3 for handling our users and its to-do list and the data, the static files. And we have used JavaScript, HTML, CSS for the front end part. And then we have added Google authentication. I'll show you further what it does, and then the objective of our project. So the objective of a project is to develop a technology which would make student lives much easier. In this pandemic time, we are almost helpless for the notes that we get from our faculty members and our teachers. So to help everyone in management, to help student in keeping all the materials in a single app. So this is what it shines. It keeps all the material in a single app or your profile, to be precise, so that you don't lose your notes or you have to search again and again, and you can download it whenever you want, or you can delete it from a local machine. So it takes care of it. So to let students study without any stress of notes in such uncertain time, which is true. And this is a literature review uh, which my uh, which my friend Gayatri will be presenting, my team member, my colleague Gayatri Shinde.
Hello all, I'm Gayatri Shinde. I'm a team member of Aryan project. So the literature review of our project, it includes the papers which basically presents a new integrated and collaborative online supervision system and dissertations projects. Then the other project, it manages the college information, then the reminders and the events going on through the colleges. Then the next paper includes the computerized process and which gives, and it has a facility which gives a unique ID to every student and store its details and the login credentials and the designs, and the main core part of the website is to be formed. We have studied more than 2 papers for our project, and it has a similar test of our project as well. The next slide. So here are some tools and components that we have used in our project that Aryan has described. Next one. So for the methodology, as the platform was new to us, we have to write code. So we have spent a lot of time in understanding the Django and it's working with the database. Then we spent our timing in finding the research papers similar to our project. Then we spent our time in creating the user interface for the website and fixing the bugs and issues regarding the website, and made it ready for the presentation. So in this way, we have implemented our methodology. Next. So here are some pages of our website that Aryan will give the demo later. So this is the progress made so far. These are the login pages, Google login page, and the further pages of our website. Next. So this is about the status of our project. We have spent our time in understanding the tools and technologies that we have used in our web app, also in the literature review, as the platform was very new to us, and implementation of various functionalities for the web app, and thus created our project. Now Aryan will give the demo.
So we have hosted our website, and it is here. You guys can check it. It's called studify2.heroku.app. I can send the link in the chat if you want. So it contains all the So I have created a I have created my account here, but I'll go through from start. I log out from this page, and I have three options here, which say sign up, login, or Google login, which gives a normal procedure of signing and logging in. But here Google login helps a lot, as it will directly give us the access to account to login to our pre-made account instead of actually making an account in this app. So yeah, I get an account directly from my VIT account, and in my profile section I get the VIT logo as my default picture, and my username and email. This is all I got. I can also change it whatever through whatever DP I want or default picture. So here is where you make to-do list to actually maintain your deadlines. So here you have added multiple things to just for the UX part of it. So concentrate on studies. We will look out for deadlines and notes. So I can name however deadlines I want. So I can say uh, dead, deadline one and create the first one. And I can say I have Vivas, that item, Vivas, I have lectures, and I can add them. And suppose I'm done with it, and I can save it. Then too, I have all saved here. And if I want to see where it is, I can just go through. I have just made it prior to this, so it still contains the same deadlines. It becomes quite helpful to manage what needs to be done and what is remaining. This is how it done. So the main part is here, the notes. The notes is where I can actually upload my notes, and it doesn't have any GB to be specified for now. So I can create a note, and I can add a note. Suppose I have this CIIR paper, and I open it. I can say CIIR final, and I can add it to my account. I could add it to my account. It's quite slow. Ah, so here it is. I have added it, and I can even download it if I accidentally delete it from my actual machine. And I can save file, open file. I can do whatever I want. I guess it starts downloading here. This is how
I
our
then
web
try
app
to
is.
wrap it up as soon as already 8 minutes
Sorry.
has passed. Well, try to wrap it up,
Okay,
like 8 minutes
okay.
has passed.
Sure. So this is what our app is, but here is our actual paper. I'll show you the paper. Here. Yeah. So this is a CIR paper. This is an abstract for it, our introduction, and it contains all the flowchart of how we started and whatever the issues we faced. We showed it in the flowchart of it, and all the references are given, and all are done in the CIR format as requested for the conference. So here I would like to conclude my presentation, and I would like to thank my uh, guidance teacher, Professor Kalpesh Joshi, for guiding us till here, and I would like to thank the national conference, for giving us the stage to present our paper. Really very grateful. Thank you so much.
Thank you, sir.
Okay, thanks so much. Is anyone having questions regarding this presentation? We can now proceed.
Anyone can ask the question, or
Yes. Anyone can ask the question regarding this paper.
so I would like to ask, in that website, if we upload the file, are we able to
Yes.
delete the file?
Yes. It has every CRUD operation. CRUD means create, read, update, delete.
Yeah, I
So you
know.
can add it, you can delete it, and it directly get deletes from the database. So it also get deletes from your account as well. So it has delete option as well. Should I show you?
A countless array of internet-based tools and platforms that increase and enhance the sharing of information. Social media has provided lots of benefit to the society in allowing people to connect easily with their friends and families and all over the world, and is allowed to break the international boundaries and cultural behavior. But society has to pay a price for this. What are the prices? Mainly, the first price that we have to pay is the social media that causes depression. And what kind of depression we are talking about here? When an individual develops classic symptoms of depression by spending excessive time on social media like Facebook, several researchers have given this phenomena a new name called Facebook depression. In social life, it is very important for someone to be accepted and also to be attached cohesively to important elements of society. Some people who suffer from Facebook depression have a high risk of social isolation and can sometimes take the route of wrong internet sites, blogs for solution. What we do, we sometimes put on our problems
Miss
or our
Anjum, I'm sorry to disturb you. I think your slides are not moving.
ma'am, yes, because I am
Acha.
explaining
All
this
right, you have
slide.
not started it. All right. All right.
Okay. The so-called Facebook depression causing psychological problems that does not limit it to Facebook also, but also to other social media networking sites. Hence, it is clear that social media is advertently leaving young boys and girls more vulnerable to becoming self-conscious, anxious, and ultimately depressed. What the teenagers used to do, they used to put on their photos and wait for the positive and negative comments. And because of these negative comments, these youngs don't accept themselves as the way they are, and this leads to a depression in their field. So we can say that among five, one is always an adult is always faced by the victim of a cyber crime. If we talk about cyber bullying, we have faced a bullying in an traditional way, but in a cyber bullying, the use of electronics and internet has given rise to a new form of bullying referred to as cyber bullying. Cyberbullying can be defined as an intentionally aggressive or harmful act executed by a bully through an electronic form of content. Contact can occur through the means of email, text, online games, social networking sites, and the bullies are similar to traditional bullying, which reverts to verbal, physical, and social forms of bullying because they involve a victim and an aggressive, harmful bullying. Cyberbullying and traditional bullying tend to overlap. Cyberbullying has found to lead to depression, as upon negative comments lead to a depression among the students or a kid. If we talk about the cyber stalking, so cyber stalking, what leads to that people used to stalk the person through an internet or electronic means, which leads to sometimes harass an individual. It can lead to a false accusations, monitoring, theft. And these cyber stalkers find their victims by using search engines, online forums, chat rooms, and social networking such as MySpace, Facebook, Twitter. Fake blogs in the names of victim are also a part of a cyber stalking, through which a person copies the IP address of some victims and attempt to verify their home or the place of their employment. And another offense that has been committed by social media is catfishing. What is catfishing? When it portrays someone, an individual who may counterfeit person-to-person communication profile. And catfishing is the way towards become a close acquaintances with outside on the web while utilizing a phony. Catfishing is usually done online dating sites or social media. We have an example of MTV. So reason why people use catfishing may be because of revenge, boredom, loneliness, insecurities. And how can we avoid it? We cannot. We have to avoid it by not joining other people who we don't know on online sites. And if we conclude, it is very important for all of us to stay away, to stay on the social media, but not sharing our each and every moment on the social media and not accepting the strangers on the social media sites to be safe from all these crimes. Thank you so much for your giving your time. I
Thank
finish.
you, ma'am. Thank you so
Thank you.
much. Our next presenter is also by Dr. Mohammed Imran on an overview of child trafficking in India. I'm guessing someone else will be presenting that.
Hello, yeah, ma'am, I'm Shweta. I'm audible.
Yes, yes, ma'am, you're audible.
Okay, ma'am, I'll present the paper on child trafficking.
All right, all right. Anjum, can you stop sharing your presentation, please? Thank you. Yes, ma'am, Shweta, you can please.
Yeah. Hello everyone, this is Shweta. I am pursuing my PhD from Shobit University under the guidance of Dr. M. Imran. My topic is a critical study of child trafficking in merit division. So I like to introduce the term trafficking first. Trafficking as defined by Cambridge Dictionary means the act of buying or selling people or making money from work they are forced to do.
Claims which are not required. Only the required contents has to be encoded. Unrequired contents can be removed using this particular provides, right? So here it also reduces the bit rate by the 40% here. That is one of the achievement here. Next is your motion vector predictions. So that is also part of a motion estimation here, right? So we require a motion vector predictions in order to calculate the bit rate from the original frame and from the new frame that is being generated after the intra prediction here, right? So this particular method reduces the motion estimation time by 81.95%, like complexity can be reduced here. And the last part of any encoder is the filtering. HEVC provides the in-loop filtering and SAO offset. So there are the two filters that work with the HEVC. That is a deblocking filter and the SAO offset. In this paper, both filters are carried on the GPU unit, and after it has been implemented on the GPU unit, so the method gives us the 47% of the reduction time here, right, for all the test sequences. So this was some of the literature survey that I have done. There are total 35 papers on which I have done my literature survey. And out of which some part is of the methodology.
Sorry to interrupt you,
Yeah.
Sally. Can you briefly
Yes.
conclude the paper within the next
Yes, So on the but as we have seen the literature survey, so this was some of the methodologies, and this was the gap analysis that I have found out. And on this basis of gap analysis, I'm working on the literature survey. Right? So from the conclusion, so this is what from the literature survey I have concluded, that there is a need for the algorithm which deals with this reduce complexity, coding performance, and so on. Right? So this is what is my conclusion from my paper. Thank you.
Thank you, Sahili, for discussing your research work with us.
Yeah.
Now we will move on to the next paper. Do we have Shubham discussing the paper titled as Study of Face Recognition Algorithms?
Yes, sir. Me, along with a few participants, will start with the presentation in just a few seconds.
Okay.
Shlok, you can go ahead with the presentation.
Yeah. Can someone please confirm if my screen is visible?
Yes, it's visible.
All right. Good afternoon to one and all. So me along with my group will be presenting and talking about our paper on comparison of algorithms used to implement face recognition. So we are from Vishwakarma Institute of Technology, Pune, and we are from the ENTC branch. So introducing my group members, along with me, Shlok Yadav, I have Shubham Dandavate, Shirish Sonje, Tanmay Tazne, and Prachiti Talgolkar. So when it comes to face recognition, the broad domain of our project was artificial intelligence. And nowadays, artificial intelligence is basically present everywhere, and which does not leave out security applications as well. So face detection is an AI-based computer technology, which is used to find and identify human faces in digital images. And as I said before, face detection also has, since AI has found its way to security applications, the connecting link between AI and security applications is face detection. One of the most basic examples of face detection is the security applications on our mobile phones. And there are a few terms which we have to go through first. For example, a classifier, which a face detection algorithm works on, is a computer program that decides whether which classifies an image as either a positive image, which is a face image, or a negative image, which is a non-face image. So in our paper, we have compared two different classifiers for face detection, which is the Haar cascade classifier and the LBP classifier. So they are evaluated in terms of their efficiency and their computational complexity, as well as the time they take. So broadly, a face recognition software can be divided into three different parts. Face detection is the first, where we have compared Haar cascade and LBP. Then we have algorithm optimization, where we explored the domain of principal component analysis, followed by facial recognition finally, where we actually implemented an artificial neural network. to basically judge its performance and complexity when it comes to any facial recognition system. To compare these algorithms, we implemented a basic mini project, which is a security authenticate application, which basically, on the basis of a user's face, it recognizes a user's face, and if the user is a part of database, it will grant access to information which is restricted from the others. So we can now move on to our first algorithm, which we implemented, the Har cascade algorithm, to which I call upon Prachiti to talk about. Do we have Prachiti?
Shlok, I think you can continue. Could be some network issue.
Right, right. So the Har cascade classification. Okay.
So as Shlok has already told about the classifiers. So
I think Prachiti is having some internet problems. So
Prachiti, we cannot hear you.
Sorry, sir, for the apologies. I think Shlok, you can continue and
I'll take over. So Har cascade classifier is a part of the OpenCV library from computer vision. And Har cascade is a machine learning based approach where an algorithm which is trained from many positive images and many negative images. So it is a pre-trained algorithm which is based on positive images which are with faces and negative images which are without faces.
That is a
Prachiti.
Har cascade.
Prachiti, can you mute yourself, please?
Yeah.
Actually, your network issues probably. We cannot hear you at all.
Hello.
Yeah. So there are windows.
Audible.
So in a Har cascade classifier, there are windows which are also called kernels, which are placed on the image, differently. It basically slides throughout the image, and there are features which are calculated based on, the pixel values of the image. And the technique which we're using here is the AdaBoost technique, which is a part of the Har cascade classifier algorithm. And if the window detects a non-face area, then it does not process it, and it focuses on the area where we have a face. For example, there are different types of kernels. Edge features here will have different kernels, windows. One part is black, one part is white. Now this black part is where the pixel value is 0, and the white part is where the pixel value is 1. So for line features, we have different kernels, and for centered surrounding features, we have different kernels. So for example, right here on the bottom right corner, we have these features. We have these kernels sliding across our image, a face image right here. To detect a line feature, we have the kernel which we're using here, and to detect edge features, we have different kernels. So this is how the Har cascade classifier essentially works. This was our first classifier which we used. Another classifier was LBP classifier, which is local binary pattern, which Shirish will be talking about.
Okay, thank you, Shlok. So Shlok, can you confirm? Am I audible?
Yes, you're audible.
Okay, so moving on with our second algorithm, which we researched upon, that is the local binary patterns. It is also an OpenCV classifier along with the Har cascade classifier. So it is basically a visual descriptor and one of the easiest algorithm to detect faces. So this is local binary patterns. And so talking about the process, about LBP, how LBP is being implemented. So we take a training image, which is divided into blocks, that is 9-pixel block each. And that window, I can say a 3x3 window, each block. So now I have the central pixel, and along with it, I have 8 neighbor pixels, right? So the central pixel is our main, then the other neighboring pixel, that is the remaining 8 pixels are compared with the central pixel. So as you can see, if the neighbor pixel value is greater than the central pixel value, then we have to threshold the neighbor pixel value to 1. Else, if the neighbor pixel value is lesser than the central pixel value, then we can threshold its value to 0. So now we have the pixel values as 1010. That is a binary number is formed. And so we have these updated pixels in a clockwise order, right? So now we have to convert this binary number into a decimal number, and then we also get a histogram. This is how the local binary patterns work. So as you can see in the figure, the first figure where where there is a name written, Bon Vivant, a French name, that is a grayscale image of our original image, and then we have an image with the LBP features. That is the second image, and as the process is being explained in the LBP features, the histogram is drawn accordingly. So 9 by 9 block each, that is a 3 into 3 window. We get various histograms, and then we get various pixel values, and then a histogram is drawn. This is how local binary patterns work. So now moving on to the next slide. Yeah, so as we have studied these two algorithms, that is the Haar cascade and the LBP, there should be a comparison between both, as they are the OpenCV classifiers. So we have considered 4 factors upon which we could easily classify both of them. That is accuracy, computation, false rate, and the training time. So I can say Haar cascade has the higher detection accuracy compared to LBP. But however, in computation factor, LBP has an upper hand over Haar cascade, as LBP is computationally simple and fast. So talking about the third factor which we considered, that is the false rate. So we can say low false positive rate is seen in Haar cascade, however high false positive rate in LBP. And so the last factor is the training time, which we considered here. That is the longer training time is seen in Haar cascade, however shorter training time in LBP. So according to these factors, I can say Haar cascade has an upper hand over LBP. So now Shubham will take over.
Thank you, Shirish. So since we're short on time, let's try to wrap this up in the next few minutes. The second and the most optimized algorithm that we need to look at here is principal component analysis. When we look at principal component analysis, we're mainly looking at an algorithm that is mainly involved in data reduction. When we're looking at data reduction, we're looking at dimensionality reduction. So usually in this particular case, we're looking at data getting compressed in such a way that most of its features aren't compromised, but are rather preserved whenever the dimensionality reduction takes place. When we're looking at PCA, for instance, which is definitely considered one of the best optimizing tools, we're looking at images. Let's take, for example, we're looking at an image which is really compressed, and we're trying to increase its resolution through various steps. Now, the goal of the PCA is not only just to reduce dimensionality, but also retain that much amount of data which is stored in each and every pixel of the particular image. When you're looking at PCA as a whole, we're looking at eigenvalues and eigenvectors. Entire dimensionality reduction is based on the concept of these eigenvalues and eigenvectors respectively. And when we're trying to do the dimensionality reduction using these eigenvalues and vectors, we're looking at these intermediate stages, in every step of visualization that we mainly look into. When it comes to, for example, testing part of it, now in every particular algorithm, we're looking at training and we're looking at testing, and then at the end, we're looking at, defining a confusion matrix about which algorithm turns out to be the best. As far as the testing part is concerned about PCA, we're looking at converting any particular image into a phase vector, normalizing it, and then projecting the vector into a space, which is usually a 3-dimensional space called eigenspace, and then trying to find the minimum distance from it. Why? Because this minimum distance technically talks about how well the model has worked in terms of computationally reducing the dimensionality while preserving the entire data set. So this is an overview of PCA. Moving on, Tanmay will explain the approach that we have taken.
Okay, thank you, Shubham. So the approach we follow for dimensionality reduction is carried out in a few steps consisting of plotting and testing. We'll be further discussing later in the presentation. The graph on the screen is visible, and it is obtained by plotting the largest eigenvectors or phase vectors of the covariance matrix that we calculate along the principal axis. The principal axis are the blue axis that we can see, and plotting in this way helps in eliminating the outliers according to the data criteria. Essentially, to explain it further, selecting the largest eigenvectors sort of summarizes the data dimensions, thus reducing high dimensional data to a lower dimensional data. This helps a lot in saving up space and speeding up the algorithm. Further, I'll hand it over to Shubham.
So when you're looking at the steps followed, in any particular code implementation technique, what is the basic things that we could do? What we have done in this project is we've taken an 8-step process where we have either, we have taken a database of images, which is our primary images, of the entire group that is present over here. Then what we're trying to do here is that we're trying to normalize it, calculate the covariance of that particular image, and the eigenvalues and the eigenvectors with respect to the image, so that when that image is basically rendered into the eigenspace, we're able to dimensionally reduce it to a particular extent where we are able to figure out how well our model is working while preserving the data. And converting all those dimensional vectors into a dummy variable, which is part of the k eigenvectors with respect to the original dimensions that we have taken into consideration. After representation takes place, the last part is just testing. And testing is one of the basic ways to understand how our model works, how efficient it is, in what ways can we improve it, and in what ways can it be more effective in terms of implementing it independently with respect to each and every image as part of our database. These are a few steps that we have implemented and which we have listed down in our entire research paper. And this summarizes pretty much about PCA. Ashlok will take it forward with the ANN approach, the last approach that we have taken into consideration. Over to you, Ashlok.
Right. Thank you, Shivam. So getting to the final approach, the final
Ashlok, you have 1 minute to finish.
Yeah, absolutely, sir. Absolutely. So getting to the final approach of our final aspect of our project was the face recognition part, where we actually used neural networks, which are structurally similar to biological neural networks, and they work on class label data set. So the data set which we used was the face 10 data set with 40 test subjects and 10 images per test subject. So how neural networks work is there's an image which is represented in terms of pixels. So since neural networks will need a number input, we cannot just feed images. So we instead feed the pixel values, there's some computation which happens between two layers in terms of backtracking, and the weights and biases are constantly updated. In the direction of the most efficient values. So finally, there's a final equation derived based on which the prediction happens. There's a predicted face ID, and if it matches the ID from a database, then the user is basically granted access. So now I think one thing is very, very clear, that AI is no more a luxury or a fad. It has actually seeped its way down into our daily lives as well. As I mentioned, the example of our phone screen locks. So that is exactly why we implemented this project. And basically, the final result is that HAR cascade proved to be a better algorithm than LBP, based on two main reasons, which is the false positive rate. So false positive rate basically is an algorithm, classifying a particular instance as positive, whereas it's actually negative. So talking an instance of our project, basically a person who's not a part of database is actually classified as a part of database. So HAR cascade has a lower false positivity rate, which is why it is it is more relevant in this case. Also the efficiency, HAR cascade is more efficient, and I don't think a few seconds faster LBP will actually offset the fact that an intruder could gain access to my data. I personally wouldn't want that. So which is why we declare that HAR cascade is a better algorithm to implement than LBP. And for face recognition, one should switch to convolutional neural networks if traditional deep learning methods are to be followed. So that's it, sir. Now we're open to questions from your side or the audience side. That's been our paper. Thank you very much.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Also, we really apologize.
Findings that consumers are saying that their high delivery time, that means when they are giving order and getting the food, that delivery time is very high. Almost 50% of our 160 respondents, they are saying the same thing, is that delivery time is very high. And another thing is they are facing the challenges is that poor sale follow-up, that is almost 24.4%. So they are saying that after giving the orders and after delivery, no follow-up at all. So these are the challenges faced by the consumer. Now I'll go for the findings. We have seen that most youngsters in this age group between 18 to 25 years, they are really availing these digital food ordering apps. And maximum this working people group, they also preferred to get their food through these digital food apps, because of they don't have much time to cook, they don't have much time to prepare on their own. So that's why they are very much depends on this digital food app. And people are like to order in a good frequency also. They are giving once in a month, once in a week. Even few people are depends on these food apps on daily basis. And these consumers are facing challenges for the delivery time, which is really becoming an obstacle, and facing the challenges regarding the follow-up after sales. So if these food digital apps companies, they can overcome of these challenges, obviously the consumers will very happy and they will be satisfied. So this was my research paper which I wanted to present. Thank you so much, everybody.
Thank you so much, sir, for presenting your paper. Now I would request Shweta Gaur and Dr. Neha Chaturvedi to please present the paper.
Yes, ma'am. Yes. So can you please stop sharing the screen? Thank you, sir. My screen is visible.
Your screen is not visible, Shweta.
Is it visible
Now
now?
it's visible. Yeah, now it's visible.
Okay, thank you, ma'am. So good afternoon, everyone. I am Shweta Gaur, and on behalf of my co-author, I will be presenting a presentation on assessing the efficacy of total quality management practices on employee empowerment in automotive companies. Next screen is visible, ma'am. Next slide.
Yes, it's visible, Shweta.
So basically, the research is primarily focusing on the study of total quality management practices and its related effect on the key contributor of organization success, that is employees. So as we all know, employees are valuable assets of an organization and key to success. So since the research on this related subject has not been yet done on the automotive sector of Uttarakhand, so we have conducted our research based on the facts and bridging the gap. As TQM, that is the total quality management, is a philosophy gradually evolved from the management theory such as quality circle, strategic planning, etc. So in this total quality management, the word total means everyone in the organization is involved in creating and maintaining the quality of the products and services which are offered by the organization. Quality basically means the degree of excellence which is being achieved with due activities. And the management is the art or way of planning, organizing, controlling, and directing to achieve a certain goal. Our next slide is to